Okay, good morning everyone. So today is the second day in measuring instruments, second day in second week in the measuring instruments. So we have things to complete, some notes, and after that move on to some questions. So, so let's go into page number 17. Page number 17. Extended vernier scale. Extended vernier scale. Right. So in extended vernier scale, we talk about them. We talk that in an extended vernier scale, not like in normal vernier scales, here the vernier scale is much closer to the second smallest division of the main scale. Okay, what? First vernier scale division is closer to the second main scale's smallest division, right? So for this we are going to find the formula to find the least count. Okay, right. So here I said that to find the least count here, we are going to subtract two main scale. We are going to subtract one vernier division from two main scales. So this gap is going to be it. This gap is this and this. Between this gap is going to be the least count. Fine. So we are going to find the least count. So I have given you some blank in page number 17 under the second para, least count equals to. So there, let's start writing. Right there. So least count is equal to value of two main scale small divisions. Division. Value of two main scale small division. Subtract value of one vernier scale small division. Right. So where are your other friends? Still outside. So after that I have given you another blank. So in there you have tried this. Under this you have tried, there's a small box. There you have tried 2 millimeters minus value of one vernier scale. There, how many coincided in this picture? Here 39 coincided with 20 vernier scales. 39 coincided with 20 vernier scales. So there what we did, we divided 39. Okay, we divided 39 by 20. So it's going to be 1.95. It's going to be 1.95 millimeters. Understand? Right? So this is going to be equal to 0.05 millimeters. This is the least count of the extended vernier scale. Copy it down. Accordingly, least count, I'll give some space. Least count is equal to least count. So you can write it LC. Right? You wrote it there. We wrote it in that place. Okay. So this is for this question, for this relevant question, but here I have given you a space to write the general equation. So both are same. Okay. There are some other types of vernier, extended vernier scales also, vernier calipers. Right. So now we are moving to another part. Okay. So here, this tube, the practical tube that I have given is a common tube for all the instruments. So from now I'm going to give some individual tubes for each practical. Okay, individual tube for each practical. This is a common tube. Likewise, I will give some practical tube, or sometimes I will bundle this up with the main practical tube. So if there are some more practicals in some units, then I'm going to give individual tubes for your easiness. Understand? So here, this is relevant to the vernier caliper part. Take this, just a tube. Take it. Is another thing. Extra application. Right. I'll in the interval, but I'll do it. Just remind me. Okay. So we learned about. Okay. So if anybody came now, you can copy this. Okay. Page number. We started this from page number. Mark them in page number 17. Page number 17. You can copy this down. So L. So in the last class, so we talked about zero errors, right? Zero errors and how to take a reading from a vernier caliper and all stuff. So what we are going to do is we are going to mention them in the nivtute, and we are going to do some small one question from each category. Okay. So take your nivtute. So first of all, let's go in the procedure wise. First of all, giving the definition for each part of the vernier caliper. Right. Okay. So in the first page, you have the labels of the vernier caliper, the parts. And in the second page onward, you have zero error. Third page, you have the zero error. Again, you have two types of zero errors, negative and positive, or positive and negative, whatever. So after that, you have some questions relevant to readings from vernier calipers and readings for the zero errors. And you have some more little questions relevant to the vernier caliper part. Okay, some structured essay questions and an essay question in the final last page. Okay, so how many left? 3, eh? Okay, so online people, when I'm telling the note, just write it in another book. So I'll send it the online PDF afterwards. So it's hard to send it now. Okay, wait. So okay, I'll send it in a few minutes. Okay, in this vernier caliper, Go to page number 1. Now let's write the description of these each parts. So first of all, you have the outer jaw of the vernier caliper. So what we measure from an outer jaw? Last class I explained that. From the outer jaw of a vernier caliper, I said normally if you are going to write a scratch of the vernier caliper, it's going to be like this. A part like this and two parts like this and a part like this. Okay, this is a simple vernier caliper. Okay, this is going to be the outer jaws. I'll write O. This is going to be the inner jaws. I'll write I. And this is going to be the depth measuring bar. These are the main parts. Apart from that, there are some simple parts. So mainly we are going to describe each and every part. Inner. So first of all, you have outer jaw, external jaw. Note it down. Outer jaws are used to measure. Start right. Outer jaws are used to measure external measurements of an object full stop. Outer jaws are used to measure external measurements of an object full stop. One of these jaws is fixed while the other is moving. One of these jaws is fixed while the other is moving. So basically this part of the vernier caliper is not moving. Okay, which part? This part is not moving. Sorry, so I said this is a little bit different. The inner part, this part, particularly this part is not moving. This is fixed with the vernier caliper. Okay, this is fixed with the vernier caliper. This is this instrument which use the vernier principle. So this is known as vernier caliper. Okay, so since this is a scissor-like part, I said inner, but inner jaws are a little bit different. So think like this: you have a scissor, okay? You have a scissor, but this hand is connected to this jaw. The right is connected to left. Okay, left is connected to right. Okay. Likewise, in this particular vernier caliper, I mean every vernier caliper, the inner jaw is tangled, a little bit tangled, like this. This is going to be connected to this left is going to be connected to the right. So every time think like this. This left side of this vernier caliper is the outer jaw. The left outer jaw is going to be the fixed. So the right of the inner is going to be the fixed. That means it can't be moved respective to the instrument. We take the instrument. With the instrument, if we move the instrument, it's going to move. That's obvious, right? But respect to the instrument, it's not going to move. But this part, which part? This part is going to be moved. Okay. So this is inner moving jaws. This is outer moving jaw. This is inner outer fixed jaw. This is inner fixed jaw. Okay, so that's what I have mentioned here. So let's go to the second one: inner jaws or internal jaws. Internal jaws are used to obtain internal measurements of an object full stop. An object. Continue to the same sentence. One of the jaw is fixed while the other jaw can move. One of the jaw is fixed while the other jaw can move. can move, while the other jaw can move. So the next part is the rod. The rod in the sense is to measure the depth. So here basically rod in the sense this is going to be the depth measuring instrument. Okay, the depth measuring bar. So right here near the rod part you have like this a rod. Okay, you have rod slash right there depth measuring bar. 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 Or we can call it the rod. Okay, rod in the sense it's from another syllabus. This is not relevant to A level syllabus. So in the resource book it's mentioned as depth measuring bar, or you can name it call it as rod. Okay, no problem. But when you are going to answer in the exam paper, just mention it specifically as the depth measuring bar. Okay. Okay. The fourth one is the main scale. Fourth one is the main scale. Before that you have to write the rod name. Rod is used to measure. Rod is used to measure. Rod is used to measure rod is used to measure depth of a hole. Depth of a hole. Depth of a hole. Depth of a hole. So if I have to explain the rod part, it's like this. Like this. So this is the bottom part of the vernier caliper. Okay. This is the bottom part of the vernier caliper. When the two outer jaws are coinciding, when the two outer jaws are coinciding, and if there's no any zero error, if the two jaws are coinciding like this, okay, these are the two jaws and they are coinciding like this, and there's no any zero error, then this depth bar is going to be inside here. It's going to be aligned with this final part of the vernier caliper. Okay. Once you start moving the moving jaw, okay, there's a moving jaw, this part, outer jaw is moving jaw. So once you start moving this part also start coming outside. Okay, so here it is 0, and from here to here you have a measurements. Let's call it as x. Let's call it as x. So if you keep this bar, you can, if you are able to keep here on something in a table like this, so there's no depth, this is flat. So the measurement is with the depth of the respective to this plane. Let's take this book. Respective to this plane, there's no any depth. There's no any depth here. There's no any hole. There's no any depth. So it's going to be 0. So once you take, let's take his no any object. So let's take a book. There's no any object. I'll draw it. Take a small nut. You'll know a nut like this. You have nut, have nuts like this. Okay. Inside you have a thread. So you are going to keep this nut like this. This is the side weave. This is the side weave. Okay. What you are going to do is you are going to keep this part. Don't shout. Don't talk. So you are going to keep this part, this red color part here on this surface, and you are going to push this. You are going to push this part inwards to this hole. You have a hole here. You have a hole here. Okay. So from that you can measure the depth of the hole. So basically to this hole is going to be the length here. So you can keep the outer jaw of the vernier caliper and measure it. Okay. Or you can use a micrometer screw gauge. But sometimes when you have a hole like this in a flat, this is a flat surface and there's a hole and you have to measure this hole. You can't insert the vernier caliper inside the inner jaw or whatever the outer jaw, you can't insert it. So this part is to measure those type of depths. Understand? Okay. So when there's a zero error, the outer jaw, the inner jaw, and the rod or the depth bar is going to get affected due to the zero error. Understand? Right. Fine. So let's go to the main scale. So this is what a main scale is. Main scale of a caliper, 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 main scale of a caliper. You need a tute. Girl name, where is she? She came. She went. Where? I don't know. Outside. Problem. She came here. Came ne? They told. Is the bag here? So once you come to class, you can go outside. Okay. After it's 8, you can't go outside. I have mentioned the intake, the starting time is 8 a.m. So once you come inside, you can't go until I give the intel, or if you have some emergency or any, if you want to shoot. Okay. Right. So main scale, where did I stop? Caliper. Main scale of the caliper, main scale of the caliper used in the lab is calculated in millimeters, that's the only thing that I have to say about a main scale. Okay. So usually it is not usually, every time it is calibrated or calculated in millimeters. Okay. Main scale of a caliper used in the lab is calculated in millimeters. Right. So the fifth one, that's the vernier scale. I give this sort of explanation because when there can be some sort of types of questions in your exam, so that's why I explain everything. So vernier scale, start right, page number 2. Vernier scale of the caliper, vernier scale of the caliper, vernier scale of the caliper, vernier scale of the caliper in the laboratory or in the lab, normally has a length of normally has a length of vernier scale of the caliper in the lab normally has a length of 9 millimeters 9 millimeters divided into 10 equal divisions. 9 millimeters divided into 10 equal divisions. So inside brackets, right, least count equals to 0.1 millimeters. Least count equals to 0.1 millimeter. Okay. So in a normal vernier caliper, it's going to be 0.1 millimeter. If they haven't mentioned the least count, if you need the least count to do a calculation, but they haven't mentioned, so what are you going to use? You're going to use 0.1 millimeters. Okay. For the sixth one, sliding jaw. Sliding jaw. Sliding jaw in the sense, how many sliding jaws do you have? How many sliding jaws? Two. Internal jaw and external jaw. One of the internal and one of the external is going to slide. And one of the internal and one of the external is going to be fixed. Okay. Sliding jaw means the sliding jaw possesses the movable parts. The sliding jaw possesses the movable parts. Sliding jaw possesses the movable parts of the instruments of the instruments of the instrument. Full stop. This includes one inner jaw, one inner jaw, one inner jaw, and one outer jaw, one outer jaw, outer jaw. There are some. Sorry. Not end here. Put a comma. Sorry, put a comma here. You have some other parts. Rod. The rod. The rod. It also moves. After that, and the vernier scale. The vernier scale also moves with the movable jaws. Vernier scale. Okay. Understand? Okay. Inner jaw, outer jaw, rod, and vernier scale. What are the movable parts? Inner jaw, one inner jaw, one outer jaw, rod or the depth bar, and the vernier scale. Okay. Right. After that, under the fixed jaw topic, right there, the fixed jaw consists of the immovable parts. The fixed jaw consists of the immovable parts of the instrument. It includes again one inner jaw, comma, one outer jaw, and what? Is there anything opposite to rod? Anything? No. Then opposite to vernier scale? That's the main scale, right? The main scale is also not gonna move. So main scale and the main scale. Okay. So the wheel, right under the wheel, one inner jaw, one outer jaw, and the main scale. And Russia. So you just write, I'll tell the topic, okay? So I said 7 topics. So I'm going to go to the 8th topic. Name it as, I forgot to tell you. The 8th topic is wheel. I'm going to describe what a wheel is in a vernier caliper, right? So right under the vernier wheel part, what's the wheel? How many wheels do you have? How many wheels? One wheel. Which is the wheel? You have two. You have like this part, and I said that you have a like T-shaped one and a half circle. So I'll name it as A and this as B. Could be there. A or B? B. Right. So I said normally wheel can rotate, but we call this wheel because it has a small grip. So normally in mechanical engineering, we call wheel for a part which is like this. It has daticular for these parts. That is something, don't know, like this part. So this is going to rotate in gears in every part. It's like its shape, a sort of wheel is there. Okay. So for that, we are going to call this as a wheel. And this part, we are going to call it as a nut. It's a nut. Okay. Also has a grip. Has a grip to turn it. But specifically, we use that not to turn. Okay. Specifically, not to touch it. We use it to lock it down. So when we are locking, we are going to turn it down. So it's a nut specifically. So the wheel, under the wheel part, write down. Wheel facilitates the sliding of the sliding jaw, the sliding of the sliding jaw, along the main scale, sliding of the sliding jaw along the main scale. Nut, right hand side, right below it. The nut is used to prevent the motion of the sliding jaw, once it reach the the nut is used to prevent the motion of the sliding jaw once it reach the relevant position. Okay, right. So before that reading, we have to do that step. So normally below the vernier caliper, you have some points. What are those points? This instrument can be used to obtain following measurements in page number 1. So we use this to measure length, width and height of a cube, internal and external diameters of a test tube. Okay, are the uses. And depth of a hole. So this girl, I don't know her name. So I'll keep one tute here. So when you're coming to the next class, just select it, okay, and write it. So okay, fine. Now and depth of a hole. So after that, you have to find the least count of a vernier caliper. Okay, now let's revise a little bit. The smallest measurement that can be measured using the vernier caliper is known as the least count. Come to vernier caliper. Least count of any vernier instrument equals to the difference between length of main scale and one vernier scale. So how we are going to find it? Least count equals to length of one division. Do I have written it out? Yeah. Length of one division of the main scale subtract length of one division of the vernier scale. So least count is equals to value of main scale divisions divided by number of divisions. Value of main scale division, value of one smallest main scale division, it's 1 millimeter. Every time this is the shortest method. And number of vernier scale divisions, normally it's going to be 10. So this is going to be 0.1 millimeter. So remember this, okay. Right. After that, measuring the length of an object using a vernier caliper. Okay, how you measure an length of an object. When the fixed and movable jaws are in contact, okay, this is the first step. So here, this is a memorizing part, a little bit when they are asking some question. So this question is going to be there. Write down the steps when taking measurement from a vernier caliper. So first of all, what you have to write is, once you take a vernier caliper, what you are going to do is, you are going to observe if it has a zero error or not. That's the first step. If you know the least count. If not, obviously, the first step is to find the least count. Okay. So the first step is, normally they mention the least count in the vernier caliper. Okay. Normally in the vernier caliper, like in here, here in a small region, they name it. I mean, they give it. This is the least count. Okay. So we don't want to calculate it. So first of all, you take a vernier caliper. What you are going to do? when the fixed and movable jaws are in contact, when the fixed jaw and the movable jaw is in contact, if there is no zero error, the zero division of the main scale must coincide with the zero division of the vernier scale. That's a must. Okay, a must. After that, when an object is placed between two jaws, when you keep an object between two jaws, the zero division of the vernier scale moves away from the zero division of the main scale. So when you keep an object here inside this part, okay, here's an object. So first of all, it was like this. Now when you move this is going to move here, move away from this, move away from the main scale's zero, the zero of the vernier scale. So move away, not move towards it, because it's aligned at the first point. Zero division of the vernier scale moves away from the zero division of the main scale. Then the measurement of the object is equal to the distance from the zero division of the main scale to the zero division of the vernier scale. Okay. Oh. Right. Okay. So I said this part, highlight this. The measurement of the object is equal to the, so girls can highlight from the beginning to the end. So if somebody who needs only the specific parts, you can underline these parts, only this. Distance from the zero division of the main scale to the zero division of the vernier scale. That's enough. That's more than enough. Distance from the zero division of the main scale to the zero division of the vernier scale. So the distance between the main scale 0 and the vernier scale's 0 is going to be the measurement of the length, the measurement of the object, right? Record the main scale division just before the zero division of the vernier scale. Before the zero division of the vernier scale. Okay, right. So what we did, so we check if there's a zero error. After that, we moved the jaws apart. We kept an object. After that, we closed it. And we fixed it. Okay. After that, what we have to do is record the main scale division just before the vernier scale. Okay, vernier scale 0. So I said it in last time, the last class. I said that if this is the vernier scale, this is the 0, and here the 0 starts of the main scale, and what you have to measure is here this 0 is going to be every time between 2 millimeters, two divisions of the vernier caliper, or it will coincide with one, this 0. Okay, most of the time 9 out of 10 it's going to be between this. In 9 out of 1 it's going to be aligned with 1. Okay, let's take those 9 out of 1 probability types. When you are going to move, if you take 9 measurements, 10 measurements, 9 out of them is going to be between 2 of these main scale division. So what you are going to do is, after you fix this, you are going to take this reading. Which reading? This part. This part, which is forward, which is in front of this 0 mark in the vernier scale. That's what they are mentioning. Record the main scale division just before the zero division. Just before the zero division, measure this main scale. Okay, right. After that, find the line of coincidence in the vernier scale. So in the vernier scale. So after that, what we are going to do? We are not going to move this vernier. We locked it here. We locked it from here. After that, what we are going to do? We are going to check which of the vernier scale is coincided with the main scale. What? Which of the vernier scale division is coincided with the main scale? Understand? So this is the which reading? This is the vernier scale reading. So after that, if the least count of the vernier caliper is y, so we are going to see which is going to coincide, and we are going to count 1, 2, 3, 4, and 5. Let's tell that fifth one is coincided with the main scale. So the vernier scale reading is going to be 5. Vernier scale division is going to be, vernier scale reading is going to be 5. So main scale reading you are going to take from here. I'll mark it in blue. Main scale, this is going to be from here, and vernier scale you are going to take this 5. Okay. After that, what you are going to do is you are going to multiply this 5 by the least count. Okay, this blue color. Yes, you can't see this color. So let's use white. Right. So you're going to multiply this 5 by the least count, and mostly it's going to be 0.1. Understand? So this is the vernier scale reading. Vernier scale reading. So after that, you are going to add this main scale reading and the main scale reading and the vernier scale reading, and that's going to be your final reading. Understand? The least count is going to be y. Then in the next page in the sense, all right. So I didn't give it in the next page because we wrote it in the last tute. Okay. After that, what we are going to do? Here I have mentioned that the vernier scale is n. Vernier scale is n, and the least count is y millimeters. You are going to multiply this by y, and the first reading from the main scale is going to be x. It's going to be x. So this is the reading. This is the reading of the vernier caliper. Understand? Main scale. This is the main scale. This is the main scale. Let's take this is x, n. This is the number of divisions. This is going to be n, and the least count is going to be y. So the final is going to be this part plus this. Okay, right. So now let's go one question. Okay, just simple one question. Okay, go to page number. Okay, go to page number. Again, from after the question this page, I have again started from 1. Okay, go to the question page number 1. Question page number 2. Question page number 2. The middle page. The middle page. This part. The middle page. This part. Okay. The middle page. This part. Find the diameter here. Here they have given. Find the reading of the following diagrams. Find the reading of the following diagram. So here I'm going to do the first one. So after looking at that, you can do the rest of the questions. Okay. First question, Roman number 1. They have given a picture, main scale, and the vernier scale. I'll mention it like this. Main scale and the vernier scale. Okay, main scale and the vernier scale. Main scale and the vernier scale. Like this, and this is. So here, what we have to do? What's the first step? We are going to take the reading from the main scale just before the 0th of the vernier scale. So here see, the 0 mark is here, and just before it, there's a small mark here, and here's the longest mark. Okay, this way. So this is going to be 6. And what is this length? Every time, people, what's the length of one main scale division? What's it? Every time, it's 1 millimeter. Every time. Okay. So this is 1 millimeter. So this is going to be what? If they have mentioned this is centimeters. So if we convert this to millimeters, it's going to be 60 millimeters. So this is 1. So this reading is going to be what? 61 millimeters. So we took the main scale reading. 61 millimeters. Fine. So I'm going to write it 61 millimeters. Okay. So what's the next part? Next step, I have to add the vernier scale into least count. Okay. So I'm going to look which vernier scale is coinciding with the main scale. Okay. Which one? First, no, it's not coinciding. Second, no, it's not. Third, it looked like it coincide, and it's obvious. Fourth, it's not coinciding. Look at the fourth. Fifth, sixth, seventh, eighth, ninth, and 10th. No any of it is coinciding. Right. So here, let's do this first question, and I'll explain a small trick. So which is coinciding? The third one. Okay. 1, 2, 3. So I'm going to write the third vernier scale. The third vernier scale is the third one. 1, 2, and the third one is coinciding with the main scale. Okay, the third one. So I'm going to write 3. After that, I'm going to multiply this by the least count. So have they given the least count? No. Is there any method to calculate the least count? No, they haven't given the least count, or they haven't mentioned a method to find the least count. So we are going to take general one. It's going to be 0.1. Okay, 0.1 millimeters. Right. So this is going to be equal to 3 times 0.1, 0.3. So it's going to be 61.3 millimeters. 61.3 millimeters. Okay. Right. Right. Soon. Right. Copy it down. Here. You can write it here. 61.3. Right. Okay. So there are more questions. You can complete them in your home. Okay. So I'm not going to touch them. You can complete them. So if I'm going to tell you a small trick, so most of the time in papers, model papers, space rules, and every whatever the paper you take, most of the time the coinciding one is not going to be clear. Here I drew it. I took not a vernier caliper, a virtual vernier caliper from the internet, and I took a photo and one by one I pasted it. So I checked if you can see the vernier coinciding part. So most of old papers and past papers, it's hard to find is coinciding with which. It's hard, really hard. This is a normal vernier caliper. If it's going to be an extended vernier caliper, you're going to have 20 vernier division. So it's a little bit harder than this. Okay. So if you can look at this picture, you can find that the third one is coinciding here. This is the third one. And if you look at the second one and the fourth vernier scale, that is going to be a little bit away from the main scale, and this is going to be a little bit before the main scale. Just look, you can find that. Can you find it? Okay. So this is how I found the reading when I couldn't find which is coinciding with which. Okay. So I drew this a torch. Do you know a torch? It's a torch. Okay. Its headlights up. The lights up. Okay. Or a funnel, whatever. So I used this to keep in mind that how to read a vernier scale. This with this and this with this, and the middle part is the coinciding one. Understand? Understand? I use these stuffs to remember. Okay. Right. So this is how you find it. So every time when you can't see which is coinciding with, you can use this. Okay. Normally not in vernier calipers, in micrometer screw gauge also they use this vernier principle, but a circular vernier principle, a circular part. In there also you can do this exact method. Okay. Right. So others are for your homework. If you want, you can write it, or don't want, you don't want to write. Just some advice. Okay, let's go to zero error. Okay, zero error of a vernier caliper. Page number 3. Page number 3. Okay. So this is what a zero error is. What's a zero error? Can anybody explain? What's a zero error? So how do you find this is a zero error? Do they mention in the gadget? No, how? Once you coincide the jaws, if the zero of the main scale doesn't coincide with the zero of the vernier scale, it's going to be a zero error. Okay, let it be in front of the zero or before the zero, it's going to be a zero error if it's not coinciding with the zero. If I tell like this, if the 10th vernier or if the last vernier division is not coinciding with the main scale division, when the two jaws are coinciding, is it a zero error? Not the 0th division, the last division of the vernier scale. It's not coinciding. When the two jaws are connected, this is just a statement. When the two jaws are connected, the last, let's take this as a normal, so they are going to be 10 division. So this 10th one is not coincided with anyone. Here, when these two are connected, or these two are coincided or collided or whatever, is it a zero error? Yes, it is a zero error. Why? I said that there's only one scenario, not I can't remember that word. What's it? Whatever. Okay, there's only in one 1 out of 10, the 0 and when the 0 is coinciding with the main scale, the 10th division in the main scale is also going to coincide with the 10th or the final one. It's better to tell the final division. Okay, it can be 20th. So these two should be coinciding. If vernier scale is 0 is coinciding and 10th, the last one is not coinciding, that's going to be what? That's not a 0 error. That's not a 0, that's going to be an instrumental error. Something has happened to the vernier scale, okay, or the main scale or something, or some division is marked, or it's going to be an instrumental error. Okay, right. A calibration error, sorry, calibration error. Right. Just write down what a 0 error is. So 0 error is when the two jaws are connected. Start write down under 0 error. We are going to write under 0 error, online students. 0 error. When two jaws are closed, comma, if the zero division of the vernier scale, if the zero division of the vernier scale does not coincide with zeroth of the main scale, does not coincide with the zeroth, does not coincide with the zeroth of the main scale, main scale. When two jaws are closed, comma, if zero division of vernier scale does not coincide with the zeroth of the main scale, it's going to be a 0 error. You can write this is known as a 0 error. You can stop there, or and you can stop in the main scale part, 0th of the main scale. That's enough. Okay. So now I said that in 0 errors you have two types. 0 errors you have two types. One is going to be positive 0 error, and the next one is going to be negative 0 error. Okay. So what is the positive 0 error? The main scale is here. Main scale 0th division. The positive 0 error in the sense the vernier scale 0 division is going to be in the positive direction. This is the positive direction. Okay. So what is a negative 0 error? The 0th of the vernier scale is going to be in the negative direction. Okay. This is every time the negative direction if you draw a number line. Okay. If you draw a number line, this 0, 1, 2 and 3, this is going to be -1. Okay. Understand? So let's write under the positive 0 error, or we can call positive 0 error as negative correction. I said it, positive 0 error, negative correction. You can call it positive 0 error or negative correction, or positive 0 error, negative correction, whatever. Both or whatever the one. Okay. If they have mentioned just only negative correction, you can use that part. Okay. When two jaws are corroded, when two jaws are corroded, really bad. When two jaws are corroded or rusted, the zero division of the vernier scale, the zero division of the vernier scale is on the RHS or right hand side. RHS, or you can write right hand side. Zero division of the vernier scale is on the right hand side of the zero division of the main scale. Right hand side of the zero division of the main scale. It's right hand to the 0 of the main scale, which the 0 of the vernier scale. It's going to be the right hand side of the main scale. Okay, that is what a positive 0 error, negative correction is. When two jaws are corroded or rusted, the 0 division of the vernier scale is on the right hand side of the 0 division of the main scale. So when does this occur? I mean, when does positive 0 occur? The reasons? When the two jaws are corroded. Okay, so the volume is going to increase, so the distance is going to be larger. Right. So In there, I have given you some blank spaces, how to calculate a zero error, positive zero error. So the second vernier division is coinciding in that vernier caliper, second vernier division. So the main scale before the zero of the vernier scale is 0. Main scale division in front of the 0th vernier scale is going to be 0. So we are not going to, the reading from the main scale is 0. So we are going to add this to the vernier reading part. Understand? If you are going to take in the procedure wise, we are going to take the reading in front of the 0 of the vernier scale. It is 0, the main scale reading. After that, 2 is coincided, least count is 0.1. So the reading is 0.2. This is 0.2, and this is a negative correction. Negative correction in the sense, to the final reading, what we should do? To the final reading, we should subtract this. Should subtract this amount. So that's why we call this as negative correction. Understand? Negative correction. Okay. So there you can write this error should be subtracted from the reading. Therefore, it is called as positive error or negative correction. Okay, positive error or negative correction. So finally, I have given you some space. Corrected value of the measurement. Corrected value of the measurement. Corrected value of the measurement. In there, write this. Reading subtract 0 error. Reading subtract 0 error. Reading subtract 0 error. 0 error. 0 error. I have given you a space name. Corrected value of measurement. Okay, right there. Fine. Okay. Now let's go to a question from it. Positive 0 error. So go to question number 12. Page number 5. Question number 12, page number 5. Okay. Here you have two parts. Let's take, there's a picture here in the page. There's a picture here. And there's two pictures in the lower part. Okay. So we are going to take this. Okay. Not this. You can do this at home. Okay. So we are going to take, what's the question? Read the 12th question. Vernier instrument with main scale in millimeters has vernier with 10 divisions. So the least count is going to be 1 millimeter divided by 10. So it's going to be 0.1. Diagram shows the zero error of the instrument and D shows a reading taken. D shows a reading taken. Okay. So B is reading. So A is the zero error. That means A is when the jaws are coinciding. Right. So the first one is, what is the zero error of the instrument? First you have to find the zero error of the instrument. So first picture they have given the zero error. Let's find it. What's it? I'm going to do the first part here. So what's the zero error? Which one is coinciding here? 1 to the third vernier scale. So I don't have to add 0 to this. It is silly. So normally this is not going to pass 1 centimeters. Okay. So normally when the zero error is going to be between 1 millimeter or 2 millimeter something. Not going to pass. It normally doesn't come to 1 centimeter something, because not 1 centimeter is going to be this much gap. So not this much part of the vernier caliper is going to correct. Okay, it's a small tiny effect, right? Mostly it's going to be bit less than 1 millimeters, right? So the which one is coinciding? The third one is coinciding. Multiply by the zero count is going to be 0.1 millimeters. Okay, right here 0 error. This is going to be 0.3 millimeters. Okay, so is this answer correct? Third one is coinciding, right? So 1, 2, 3 multiplied by 0.1, 0.3. Is it correct? What type of zero error is this? What's the type of this zero error? This is a positive zero error. So what's the correction type? Negative correction. So when you write a zero error, a positive zero error, which is a negative correction, you are going to put a subtraction here. You're going to put subtraction here. Okay. Unless they have mentioned find the type of the zero error. If they have said find the type of the zero error, then you don't have to find this negative part. So here they haven't tell you find what's the type of the zero error. They haven't mentioned here. So this is the zero error. You have number 1, I have given you blanks. Okay, in there write this part. Write this part. Boys, you're talking too much. Here, write this first. Yeah. Yeah. Okay. Second, they have said, what is the reading of the instrument? What is the reading of the instrument? So here in the first example, they have given 2 readings in the above figure. In the page, you have 2 figures here. They have said A is the zero error, B is the reading. So to the second part of the question, which reading are you going to take? A or B? Which reading? B. Okay. So what is the reading of the instrument? Just they have asked, what is the reading of the instrument? So just we have to write the reading of the instrument, only the reading of the instrument. We don't have to correct it, right? So let's find the reading of the instrument. Reading of the instrument. Reading of the instrument. We have to erase this. Right. So first of all, what we have to see? So whenever you leave the class, just inform me. If she's there, Manjula is there, inform her. Or if there's a responsible person here who is inside this institute, just inform them. Okay. Right. I hope this fault doesn't occur again. Not like math classes. So in math class, there are tons of students. So if one student is missing, it's not considered. It's not that much error. I say the absolute error is really low. But here, normally it's going to be if normally the number of English medium students is less than 50 or it's maximum 50 to 60. We take mainstream students, max or bio. Understand? Right. So 1 out of 50 in a sense is going to be 2%. A big error, larger than 1%. Understand? So here Ratnapura, you are English medium students, you are special. You are really special. So whatever you do, you are marked. If anybody see you and if anybody know that you are English medium student, they are going to mark that this is English medium student, so special. So in Colombo, there are a ton of English medium students. No worries. Okay. Some of them have put island branch, but not in Ratnapura still. So only the first, I don't remember. She's from Lyceum. Her name is, she was district first. What's her name? Deepna. Right. He was the first student, I guess, for the history. Okay. He was island 29th. So still, there's no English people who passed that rate. So you can think that, how many districts do we have? How many districts? 25 districts. Okay. So some districts have obtained double of ranks, island ranks in the history. Understand? So we are English medium people in not in Sri Lanka, in Ratnapura is in a little bit worse phase. Okay, so you have to break it. I break it. You'll have to break it. I was the first government student. I mean, I was the second government student because one of my friend was district 70th. I'm district 90th. But normally, I said due to some reasons I got district 90th. It's not possible for me to become district 90th. If the exam is going to happen before 2 or 3 months, I am going to be in the top 10 list. Because on the last 2 months I got some effect. My dad got affected, his surgery, so I got mentally depressed, and so I got to those friends. So I didn't study for 2 months. Study in the sense I didn't open a book. I was that much angry with this syllabus and with the education. Okay, due to my not my faults, due to environmental things. That's why I became the 90th. If not, I'm the first student, the government school student, English medium, who got a rank and who went to university. So in government schools, there are no people. I think there are no people here. So from Lyceum, they are students, because Lyceum, they are a little bit rich people there. Okay, so they go to individual classes and how they manage and they can pass. But normally in government school students, why they go to government school? If they have a small amount of income, not small sum. Some really high income goes to government schools also, but normally the general is uh, with middle class families go to government schools. Understand? So it's up to you. You want to break it or not break it. So recently, another English medium student also from Sivali, the last batch, district second or something from Max, district second, Abito, I can't remember his name, Abito something. So you have to do some record here. Okay, the English medium students in this, you are going to be very special. I said you all, I was going to a maths class, maths class, Ferguson teachers, Iomis. She did it in Sinhala medium. So I was noted in the first 2 days when I'm doing class, because I did the sums really fast. Not just fast, I did before the teacher did the questions, and I continued to almost 9 to 10 months like that. No one can catch my speed. So like within 1 month, my name was that much famous that teachers who didn't I haven't seen know my name. I was just a student from the private school, JMC. You'll know JMC, it's here. Okay, it's private school, it's a small school. Understand? I was that much noted by. So normally, single medium school students, they can do stuff. They are patta bright. Okay, but what's the difference with me? I'm English medium student. That's why I was that much famous than other students. Okay, so when you are just getting sleepy, I'll tell there are a lot of stories. Okay, so whenever you are English medium student, just think a little bit of it. Okay, okay, right. Be a little bit responsible. So in this reading, first of all, when you are taking reading from the vernier caliper, what you're going to do, you're going to take the main scale reading, which is near the vernier scale reading. Okay, what's it? So you have the vernier scale 0th mark, and before that they have 2 marks, and this is going to be how much millimeters? 1 millimeter, 2 millimeter, 3 millimeters. So 1 centimeter, they have mentioned 1 centimeter here, 1 centimeter. Here, this is 1.1, 1.2, and 1.3. This is going to be 1.3. 1.3 in the sense, how many millimeters? 13 millimeters. So I'm going to mention it. Reading, I'm going to start writing. Once I'm going to question, I'm going to start writing. Reading equals to 13 millimeters, 13 millimeters, 13 millimeters plus 13 millimeters plus. After, what are you going to do? See which is coinciding with which. So which is coinciding? 1, 2, 3, 3, 4. Fourth one is coinciding. So it's going to be 4. And the least count is 0.1 millimeters. So the reading of this vernier caliper is going to be 13 plus 0.4. It's going to be 13.4 millimeters. Did you all understand, people? You understand? Okay. Under the second part, you have tried this. Second, number 2, reading equals to 30 millimeters plus 4 into 0.1 millimeters equals to 13.4 millimeters. Okay, right. This is the reading, but we have a 0 error, and that's negative correction. Understand? So this is the reading, but this is not the actual value of the measurement. But we have to subtract the 0 error. Okay, 0 error. Fine. So after that, in the third step, what we are going to do is we are going to find the corrected reading. So I said that the corrected reading is corrected reading. This is going to be equal to 13.4 millimeters. Subtract, what's the 0 error? 0.3. 0.3 millimeters, and this is going to be how much? 13.1. Okay, 13.1 millimeter. So this is the reading from the vernier scale, vernier caliper. Okay, write it. So in the 12th question, I have given stepwise 1, 2, 3. Okay, stepwise 1, 2, 3. But in the 13th question, I have given space for 0 error. Reading and corrected value, I have given 1 space. Okay, in that space, you have to find the reading as well as the corrected value. Understand? Right. Now let's go to the negative correction. Okay, page number. We are going all over the dude. Nice. Okay, again I'm going to mention that you have 3 types of tute: practical, theory, and question tute. Okay, in this practical, since you are still the beginning, I have to give a lot of effort to give you the theory. Okay, understand? If I'm going to cover this part fast, then you are going to be in a miserable place. Okay, so that's why I divided again the practical tutes into several types of tute. So the main tute, it mentions the common parts of these 4 practicals. So individual tutes I will provide. Okay, this is a small part, and while I'll take 2 hours from it and complete this tute. Okay, so since we covered the vernier caliper, it's really hard. Okay, because that's the first practical. When you're going to micrometer screw gauge, that's going to be a bit easy. If teach you all 0 error in a micrometer screw gauge, it's really easy. Okay, I can tell positive, this is in the positive side, this is negative correction, that's all. And this is in the negative side, it's going to be positive relation. Okay, fine, let's go to the question. That's all. Understand? This is how your brain works. When you go in a path, when the neurons go in a path, after it knows the road, it moves, it can move in that road much speedily before the first time, the second time, third time. Understand? Right. So from this you can take a quote, but practice makes you perfect. Okay. So fine. So let's go to the negative 0 error. Negative 0 error, positive correction. So here, right there, under the topic, page number 4, before the question part, when 2 jaws are worn out, before that, if you have a highlighter, in the positive 0 error part, highlight rusted or corroded or rusted. Highlight that part, corroded or rusted. So there can be questions from that part, corroded or rusted. Corroded or rusted. Here under in the positive 0 errors definition, corroded or rusted. Highlight it, because they can ask, how can a positive 0 error occur? How? What are the ways? So the jaws can be corroded or rusted. So here you have to highlight the worn out part. In negative 0 error, come back to the negative 0 error. When 2 jaws are worn out, when 2 jaws are worn out, or wasted, not wasted like in GTA. You die, it's not wasted. Wasted. Is it wasted? I'm not a game guy, but I have small experience. When the 2 jaws are worn out or wasted, the zero division of the vernier scale, zero division of the vernier scale is on the LHS or the left hand side. Zero division of the vernier scale is on the LHS or the left hand side. So don't write LHS or the left hand side. This or this, this or this. There are people who write like that. I know that they are friends of mine. Whatever the teacher say, he's not in concentration, he's not in focusing. So whatever it is, he's going to write. Now look at the board students, he's going to look at the board students. Okay, they are silly guys. Okay, left hand side of the zero division of the main scale. My goodness. Sorry, online students, what happened? So when I was stepping to the stage, that part slipped away. Yeah. It's a little bit slippery. There's a small defect in this instrument. I mean this camera. There's a nut and that nut is pushing this away. So the camera is going to be every time a little bit standard. To balance it, I have to keep something here. Oh, first of all, like taking the zero error from the vernier caliper, once I come to the class, I have to keep something there. Okay. So what I was mentioning, vernier scale, I'll read again. When two jaws are worn out or wasted, highlight the worn out or wasted part. The zero division of the vernier scale is on the left hand side of the zero division of the main scale. Left hand side of the zero division of the main scale. So max people who are in trigonometry these days, trigonometry started. Very boring. Then trigonometry was the first part which I geared up. I can do trigonometric those equation LHS equals RHS more than a formula car. Can do that much. But you have to keep that speed. What happened to me was, like in the first year, I was that much speed. In second year, since we are not revising the first year stuff, I got a little bit slow. And when I was doing questions, I was like really slow in max. So that was the really affected part. I said in max I had B. I didn't practice that much max question because I knew I was like big-headed. I know max. Like without studying max, I get higher marks. Okay, every time. So I got big-headed in the second year. I can do max 9. Don't study. Don't become big-headed when you get rank. Okay. I have every sort of experience. So okay, the zero error part I have given how to find the zero error. Here now this is a new part. That guy, especially that guy. But I don't know what's your name? Huh? Hmm? Akila. What? Lakira. Okay, Lakira. That was the only person who asked this doubt. Okay, who asked this doubt. Fine. Let's see if anybody understands this. Okay. Now what I did in last week was I had the main scale. Okay. This is main scale zero division. This was the vernier scale's zero division. Let's see. This is the zero scale's 10th division. What I'm going to do is here this coincides with the 9th one. Right. What I'm going to do is I'm going to take this part. Okay. So when I move in this direction, 0.1 millimeters, the first one is going to, okay, fine. When I move this in this direction, 0.1 millimeters apart. So what's going to happen? The first of the main scale is going to coincide with the first of the vernier scale. Okay. When I move in this direction, okay. Now it's coincided. Now I'm going to move. Now think I can move in this direction also. Okay. I can move in this direction also. So let's cancel this off. I'm not going to move this part. So what I'm going to do is I'm going to move in this direction 0.0, not 0, 0.1 millimeters in the left direction. Which vernier scale will coincide? You have to think 10th is coincided with 9. This is coincided with 10. Here you have 8th division also. Here you have first division. So in this direction, first one coincide with first one. If you move in this direction, if you move in this direction, which one will coincide with which one? The 9th one here will coincide with the 8th one. You'll understand. So here, if I make it much clearer, I can draw this in the torch diagram. Here 0 and the 0. Okay. Here 9 and the 10. Okay. Here you have 1. Here you have 1 here and the 1 here. Okay. And here you have the 8 here and here you have the 9 here. 9, the small one. No. 9, this 1, and this is 8. So this is going to be 0.9. Okay. Don't mind about my letters. Okay. I can't write really hard. So this is going to be 0.9. This is going to be 0.9. And this is going to be 0.9. Okay. Shh. Look at the board. This is going to be 0.9. This is going to be 0.9. So this is 1 millimeter. That means 10 This is 9 in the sense this is going to be 10. This is 9, this is going to be 10. So this is 1 millimeter, this is 0.9 millimeters. So what is the gap here? I'll take a red color. Okay, pink color. Girls, what's this gap? 0.1. Right. Boys, blue color. What's this gap? What's this gap? 0.1. Okay. So once I move in this direction, 0.1 millimeters, which one is going to coincide? This 9th is going to coincide with the 8th. Understand? The 9th one is going to coincide with 8th. So I'm going to ask a question. Will another division in the vernier scale coincide with the main scale? Another one, other than 9th one, will it? No. I said only 0 and 10 is going to simultaneously coincide. But here, when 9 is coincide, no. Right. I moved only 0.1. Okay. Let's go to this part. So, when I was moving in this direction, that is the girls' direction. Let's take it, girls. When I was moving in this direction, I moved 0.1 millimeters. Can you see this color? 0.1 millimeters. And which one was coinciding? First one was coinciding. So first one multiplied by 0.1 least count is going to be, the reading is going to be 0.1 millimeters. Okay, I moved this much. Now the zero error when I'm going to move in blue direction, I mean in the left direction, that's called as negative zero error, positive correction. That means I'm going to add that part. I'm going to add. So I moved it 0.1 millimeters away. Can you see this blue color? Online students, can you see it? Put a Y if you can see this blue color. No eyes. Yeah. Okay. So I'm going to move this 0.1 millimeters. So which one is going to coincide, people? 9th one. So the 9th one. Okay, this is I can't see it. You can see it, but I can't see it. I'll write it in white color. Okay. Boys' favorite color is white. Okay. Pink for now. Just assume. Let's assume. It's just a myth. But boys don't like blue color. 9. Okay. I'm going to multiply this by 0. As the procedure, what I will have to do? I have to find which is coinciding, multiply that by least count. Found which is coinciding, multiply that by least count, that's 0. This much, but it is going to be 0.9 millimeters. The reading is 0.9 millimeters, people, but here I have moved only 0.1 millimeters. There's a contradiction. There's a contradiction. That boy found that. Okay. To be honest, he was leaving the half of the class. Okay, after it, I don't know, but there are some people who has that much talent in OL class. Also, I have people sort of like he's not looking at the board, but he knows what I'm teaching him. Okay, that's good talent. Okay, so he asked this question. If we move here, I said that we are going to subtract. I did it also. I said this is going to be move 0.3 millimeters. I'm going to add this part the final reading, but no. In negative zero error, positive correction, what you are going to do is you are going to take a like now this reading should be 0.1. Okay, so should this change? This is the least count, so that should not change because the instrument we are not changing the instrument, but this 9 should change, right? So this 9, how to make this 1? Let's take whatever x plus 9. Okay, this should be 1. What this x? Okay, sorry. Okay, whatever this x is going to be. Minus what? Minus 8. But is the minus 8 is not obvious, right? So this 9, how this comes here is, so here this is not the addition mark. Let's put it as a subtraction mark. Okay, x is going to be 10. Okay, this one comes like that. Now you have 10 division, people. 9 is coincided when you are going to negative correct, positive correction or negative zero error, positive correction. What you do is take the coinciding part, subtract that from 10. 10 in the sense the total number of vernier scale divisions. Then you get 1, and that is going to be multiplied by the least count, and this 0 is not going to come here. What's it? It's going to be 1. No, 10 minus 9. It's going to be 10 minus 9. Okay, so here it's going to be, I'll write again in blue, it's going to be 10 minus 1, not 1, 9. 10 minus 9. Understand? Okay, this is the difference in um, negative 0 error. Okay, so I'll explain this much clearer by using a little small scenario. Usually this scenario is used in mathematics teachers use this part to explain here like this. If this is x plus 10, x plus 10 equals to x plus 10 equals to 5. What you're going to do? You're going to put this x here and subtract this 10. You're going to put this here. You'll know this. But if I teach this to small kids, they are going to be, this is like magic. Wow, this is going to be minus. Does that happen like that? No. What you do is you subtract minus 10 from both sides. So this 10 to this 10 cancels off. That's how that minus 10 comes. Okay. So to explain like this sort of stuff, there's a small scenario. You take a shoe. Okay. You have put a lace shoe. Okay. When I'm going to wear a shoe, how do I wear the order? First of all, obviously I'm going to wash my legs. Okay, and dry it up. I'm going to put the socks. Let's assume this is a socks. Okay, this is a sock. Okay, so I'm going to wear it. Wear it. So I'll go right. Wear it. Wear it. Oh, I think mostly my English grammar is correct. Okay, wear it. Mostly it's going to be wrong. Okay, I just said it. Wear it. After that, I'm going to put on my shoes. The shoe lace is not tied up. Put on. Okay. After that, I'm going to tie the lace. Tie the lace. Okay. This is when I am getting ready. So once you go to your home, you're going to remove this. So first of all, what are you going to do? You are going to do the last step at first. Last step at first. So lace is going to be tied. Last step at first and the inverse of the last step. Understand? Last step at first and inverse of the last. So I'm going to untie the lace. Untie the lace. Okay. After that, shoes. I put on the shoes. Now I'm going to remove the shoes. Remove the second. Since there are only 3 steps, it's going to be again the second. But if there are 4 steps, if the steps are going to get upside down and the process is going to be inverse of it. Okay. We are going to remove this. And here I wear the sock. Here I'm going to remove the sock. So this is how you explain when you are doing a process and when you are undoing it. Okay. So I got this example to explain you all. When you are moving in this direction, okay, you add stuff, subtract stuff. When it's going to in this direction, you are going to subtract stuff. So when you are going here, you are going to take that 1 and multiply that by 0.1. But when you are going in this direction, you are going to subtract stuff. Understand? Right. That's how this 10 minus 9 comes. It's the inverse of it. Okay. Right. If you'll think this, I can explain this much more. Think this deeply, then you will understand what's the connection between that process and this process. Okay. Right. So you will write those stuff. No. I have given that. Okay. Go page number 4. 0 error. This is 928. 0 error equals to. So this is the nib formula. Nib formula. 0 error. What's 0 error? Negative 0 error. This is going to be equal to total number of vernier divisions. Here I've done a small mistake, right? Here I have put this mark. I erased it again. There was this exact error in another page. I erased it, but here I have forgotten to erase. Okay. Here what you have to do is you have to erase that line. Okay, the line which is between here. Total number of vernier divisions, vernier scale divisions. Okay. I have put this mark here, division mark. However, you have to erase it. Just cut it from another color pen. I'm going to be like this. Cut it. This is going to be multiplied by total number of vernier scale division. Here again a small mistake. Not a small mistake, that's a huge. Okay, let's write it again. This is going to be not multiplication, this is going to be subtraction. So this is a little bit practice since I have not erased all of its stuff. Coincidence of vernier scale. Okay, so total number of vernier scale is going to be, what's it, 10. So I'm going to okay. So here lines of coincidence, for example, this is 10, here we got 9 and we multiplied that by least count, least count. So this is how we measure zero error. Okay, so what you have to do is erase this mark from a pen, erase this mark from a pen, erase this multiplication and put it as a subtraction, put 2 brackets and multiply like this. So finally you can fully cut this and write it again, or you can adjust this. Let's see what you will do. You got it. So it's better to rewrite it, right? Better to rewrite. Just fixed. Okay, whatever, do it in the correct way. After that, here the 7th one is coinciding here. So 10 minus 7 in this example, that's going to be 10 minus 7. Okay, 10 minus 7. And we are multiplying this by 0.1. And it's going to be 3 times 0.1 millimeters. It's going to be 0.3 millimeters. Somebody can ask why you are writing it much big letters. Hard to write small letters. So now you can see friction. You know friction. Advantages of friction. In a whiteboard, there should be a little bit friction. If the friction is really low, it's hard to write. So people who use that ink pen and ballpoint pen, it was really hard. Those times it was really hard to transform ink pen to ballpoint pen. Why? Ballpoint pen just slides, sing. But ink, it's like this, like this, and it's nanoscale is going to be a like little bit part here, and the ink flows here, like this or something. I can draw here. It is sort of stuff. So there's a point there. So it's going to make a little bit friction. It's like right. But in ballpoint pen, there's a ball. Do you know roll-on perfumes? Roll-on perfumes, like deodorants and all. Here you have a ball here. That's a pen. That's how your pen nowadays pens works. There's ink here. There's a ball here. Tiny ball. I don't know how they fix this ball inside this. Really, there's a tiny ball, and when your pen gets leaked, sometimes when your pen gets full, it's leaking. What happens then is it's a really super a structure here is here, and there's a curvature, and there's a small gap here. Okay, this is a really small gap. I dribble like this. When the pen goes and crashes on the ground, this ball goes here, and this gap becomes a little bit huge. So this ball can move here and there. So this gap is going to be huge compared to previous. So here there's going to be a lot of ink than the previous stuff. So this can move here and there. When this move here, the ink is going to come out. How did I think this stuff? When I was sleeping. You will get these imaginations when you're sleeping. No, don't sleep with phones, and these days you are sleeping with phones. I don't. No. Right. Okay. So zero error is finished. So let's go to question number 14. Go to question number 14. Really hard these students to do. Wait. I'll check if I can send this different. I'm stuck in WhatsApp. There's a hell a lot of process going in my laptop. One studio recording, tethering. I have to send it back. Okay. So now, how many of you all filled the application and give me 7? There was 7. 1, 2, 3, 4, 5, 6. Everyone. Absent. I think she's in online. Prabhisha was last week. You didn't give. Okay. Gave 3, 4, 5, 6. 2 of you didn't give. Anyone there? No. I'll check. 7. So you all didn't fill 2 twice, ne? Papers. Okay. So whoever you will have the application. No. Have. Did you fill it? If not, take just 10 minutes and 10 or 5 minutes, just fill it soon. Fill it. If you don't have, I can give again. I need to 1, 3, 4, 5, 6, 7. And Meru, you. Okay, there's 7. Did you hands up first? Then there's eye problem. I have an eye problem. uh, okay, this is the tute. I sent it to the group. You can download it. Sorry for sending it late. There's a small technical issue here. So again, last week. Last paper class recording, I didn't upload it. I didn't upload the last paper class recording because I changed some settings in this laptop, and that video was 9 GB. Okay, so I can upload it. However, I can upload it in night time. I can upload it. However, but the thing is, when you're going to watch, it's going to really stuck. Okay. However, the quality is going to decrease 9 GB. In sense, it's going to be almost 6 GB. Let's guess it. But however, when you are going to see it, it's going to get really stuck. Okay. So I didn't upload it. So I have to I have to reduce the quality. To reduce the quality, it gets 2 days because that's a huge one. I choose an encoder. This is a really big part. So I'm going to give that recording to some people and I'm going to do it. So the last recording is going to be a little bit late. Okay. So I have to upload another 2 recordings also. I got what? Stumble with all the recordings. I named it with the dates. Okay. Whatever happened to my hard disk and every got they have been renamed. Okay. So again I lost the order how I sent it. So there are still pending 3 recordings. Okay. Watch the recordings that you can watch. So other recordings I'll post it and I'll post every time the order of the recording. You don't know which recording is there. So this is the next time I'm going to do like this. In the description of the group, I'm going to mention theory class and paper class. So paper class 1, the YouTube link. Paper class 2, YouTube link, like that. Okay, like this stuff. So once you fill the application, what I do is I'll give access to this. Now whoever taps the link can watch the recording. Whoever you send to one of your friends is not coming to the class, one who is in in another foreign country, they can watch by tapping, but can't watch the recording by searching it. It is not as unlisted. It's a feature in YouTube. Okay, so this is public. Normally this is public. Whoever touches it, he can record. So I can't do this forever. So it's going to be unfair for you all. I can do this, no problem, but it's going to be unfair for you all. Understand? So what I'm going to do is from next month, I'm going to give access to the email addresses. So if you want to watch the recording, you have to log into that Google account and log into YouTube to watch that recording. And after that, I'm not going to post recordings into group. You'll have to subscribe the channel. So it's going to come to the end. Okay. It's because it's really hard every time to put the prompt and not hard. It's easy. I can automate it. The thing is, once I forgot, it's going to be really messed up. So every time you finish a class, the recording is going to be posted in the next day. Almost within 12 hours, I'm going to post the recording. Okay. Right. So you have the recording. You can come physical. You can join online. But the best practice is to come physically. If the facilities to come here is really easy. Okay, if you're coming from kilometers, if it's hard, you can come online or watch the recording, right? Okay, so in this, likewise, I'm going to give 1, 2 and the paper classes. So for now, the free classes will be listed in the description, so you can watch whatever the recording you have missed. Okay, right. So it's 9:43. So who is filling the applications and who didn't? You filled. No, lighting up. You got it. Filled. You want an application. That means you didn't take the identity number. Okay. However, I'll give this application. Oh, you have now. Okay. So you need one. You also need. Don't worry. Do you know the ID card number? So how many of you all need application? You have finished filling it. You, this one. You gave. You filling. You need. Write your national ID card. Okay. So everybody gave. There are 2 people in online. So really, it's really impressive to see your ambitions. Different types of ambitions are here. To be honest, in our days, if we ask ambitions from 10 people, it's going to be engineer, doctor, engineer. That's all. That's going to be the answer. Just engineer, just a doctor, just a something. So 1 or 2 is going to specifically mention, I am going to be this engineer, I'm going to be this consultant, surgeon, or whatever. Here, if you take one have mentioned doctor, there's an engineer, okay. So agricultural researcher, again engineer. Yeah, there was something weird. Commercial chief pilot. Awesome. Doctor cardiologist. Cardiologist in sense heart stuff. Ne? Who is that pilot guy? So commercial chief pilot. Chief pilot in aeroplane. So in you can be pilot in. No, that's captain. Ne? So if you are going to be a pilot, there are some conditions. You have to this much height and stuff. There's a little more limitations there. So it's going to be really, you should have a super duper money to become a pilot. It will cost almost 3 crores or something. Uh-huh. Mm-hmm. Sure. Uh-huh. Keep saying that. Should have good emotional balance, and you should know to balance your emotion. However, when you are going advanced after the A levels, you should have a what how to tell, you should know to manage yourself, your academics, your life, your emotions, every stuff. You should know how to manage them. So what I was going to say is, I love to be a pilot because there are a lot of buttons there. Okay, levers, buttons. I love to click buttons. When I have whatever the gadgetic, I click everything. Do what the thing that I can do with that gadget, I do every stuff. Whatever the thing I can do, I do it. So sometimes that instrument get lost or it gets mistouched or something. So uh, those days they said that you should have a brother, you should have two brothers if you have to become a pilot or something. Was there a condition like that? Uh-huh. Mm-hmm. Mm-hmm. So in those days, ladies can become pilots, right? Nabil can. Okay, finished. Gmail is in simple, fine. So be aware of your email address. Huh? If you didn't mention it correctly, someone is going to get access. Okay. Hmm? It should be in character. I didn't give the instruction. I gave an example. Okay, whatever. If you have written any simple letters, it's better. Not it's not better, but it's fine. Give me. Okay, I have only you two people and you. This one. So I have to pick only three. Okay. So, right. Soon, soon, soon. Just call me when you finish right now. Right. Now we are going to go. In this tute, just a little bit more errors, erroneous. The last page, go to the final page. Close the book and go to the final page. This page. Okay. Here, the main error is you have two vernier. You have two vernier parts here. You see, here. Here you have two parts. Okay. Here, if you watch it correctly, there's no vernier scale which is coinciding with the main scale. No any scales. Okay. So you have to adjust that. Uh, in the first one, in the first diagram, make it 1, 2, 3, 4, and fifth one. 1, 2, 3, 4, 5. Fifth one, coincide it and put an arrow here and fifth vernier scale. Okay, here is the 0, here is the 0. This is the first diagram in page number 7, last page. Okay, fifth vernier scale is coinciding. Assume that is coinciding. Make it a little bit darker. Okay, the point here is not finding the coinciding part. Okay, the point in the physics paper they are going to see if you can calculate it. They are not going to check your vision. Understand? So it's okay to mention that the fifth one is coinciding here. Okay, right. In the second diagram, again there's a mistake. In the second diagram, you should coincide the 1, 2, 3, 4, 5, 6. Sixth one. Here the sixth one. 1, 2, 3, 4, 5, 6. Sixth one. Sixth vernier scale. Sixth vernier scale. It's going to coincide with the main scale. Okay, think like that. Assume. In this diagram. Okay, diagram. This is the first diagram. This is the second diagram. Fine. And okay, finished. Did you correct it? People, boys, did you correct it? No. Soon. In the last page, first diagram, there's no any vernier scale that is coinciding. In the second diagram also no any. So here assume that fifth one is coinciding in the first diagram. Second diagram, sixth one is coinciding. And there's a small part also. After finishing this, let me know. So other people can continue this. In the big diagram here, the vernier caliper here, you have the internal part and internal jaw, and you have the external jaw. So this length they haven't marked it. Put an arrow mark. I'll mark it in yellow color. So put an arrow mark here and mention it as D. This is D. Okay, they haven't given it D. You need this data D. The distance between internal jaw is going to be D. This part and this part. This. Okay. And here you have the lock, right? You have the lock here. Put an arrow or just put a C near that lock. So C in the sense is going to be, they are going to mention the lock. If they are going to ask any question about C, it's going to be the lock or the screw or the nut. Okay, so that's all the small errors in the cute. Fine. So if there are any other errors, just let me know when you're doing questions. So here we have done 0 errors, positive and negative. Okay, so you can do sums before learning 0 errors. You can do up to the bunch of number 1 questions, bunch of number 2 questions. So bunch of number 3, number 4, number 5, number 6, number 7, and number 8 until number 11. Okay, fine. So there you should be aware of the least count. In the 12th part, you have 0 errors. In the 14th part also you have 0 errors. Don't get confused. If there's any error, just let me know. Just put a message to that WhatsApp number. Okay, the number which I'm putting messages in the group. And after that, you have the essay question. Fine. So next class or after this is 9th May. Okay, this is 9th May, right? So before this month is going to finish, you should buy a Pesuru MCQ book as well as the Pesuru structured essay book. Okay, specified. So after that, after I'm covering this, I'm covering each part. I'm going to tell you can do this number, this number, this number, this number. You have to try those numbers. You have to bring the Pesuru every time. When you're traveling by bus or whatever the vehicle, you can try them. Okay, MCQs. I did that stuff. I didn't have much time to do the Pesuru MCQs. So when I was traveling in the bus, I was doing not when I'm standing, when I'm sitting in the bus. If I have time, I do these questions. Okay. So when people are looking at me, this is a book bug. What was that? Name? Something. Something. Just they just bully me those times. But I didn't consider that. Like I have to complete them. If not, if you complete the Pesarus, you get a super duper confidence because those are the past paper questions. Okay, then you know, I have the theory, I can do the questions. Perfect. That's all. That's all you have to. That's the final conclusion that you have to have in your mind. I know the theory. I can do the questions. Which questions? Past paper questions. Huh? Model questions, if you can't do, that's all right, but you must try to do it. Model questions are a little bit hard and sometimes it's out of syllabus. Understand? Fine. So this tute is completed. Okay, this tute is completed. So yeah, this is completed. So now we are going to go to the previous tute. So this is going to be 10. So there's a 956. We did extended vernier calipers. Tute. We fill the errors. And after that, we have to go to error estimation and circular vernier scale. So the error estimation part is a little bit huge in the sense you have to give a focus to approximately 45 minutes, then you will get it. So before going into the error estimation part, you can have the break. Okay. How many minutes do I give the break? 15 minutes. Yeah. This is 9:56. Take break and come at 10:10. 10:11. 10:11. Okay. Yeah, 10:11. 10:11. Okay. Online people, can you hear me now? That's it. What's the difference now? Any difference in the view before and now? So this is a dark class, dark room. Okay, so attention, attention, pay attention. Where's those applications? Field ones? No, I didn't get it. Do you? Only that. Yeah. No, okay. Kelly goes is it XELIGOS? That's how you write S. It's like that Moena's logo. It's like this, ne? I haven't seen an S like this before. Huh? Yeah, that is. That's this, right? Three father Mavata Mavata Ratnapura. My goodness. You haven't kept space, ne? You have to read this 234 Sripada Mavatar. Everything is right altogether. Sripada Mavatar Ratnapura, everything. You have to keep space. And you have to keep you have to write them in capital letters. After the older school, ICM International. I have given you plenty of boxes. Do you know how much hard this was to make the application? My God, I got 2 days to make this. Yeah, it was just the beginning making applications. I could give you all to fill in the blanks, just dotted lines. But more than that, this is the most accurate thing to take details. So you should fill again that one. You should fill it again. So it's hard for me to read it. Take this, fill in capital letters, keep spaces, dashes, O level. You are A level, right? Still ordinary people, some advanced. So I have here 1, 2, 3, 4. How many of you all gave me applications today? Today, you, you 2, 2, 3, and you 4. You gave today. This is yours. And Nethula, you right. Dimbul PTS, Ineja, that's your one. Mahen, 3, 4, 5. One. I missed you. Just check. Is it with you? See? No, no. Your one. You gave it today. Last week. You hands up now, ne? Very good. Seeing in everyone. So 4, okay, ne? That 1, 2, 3, and you 4. You have to give 5. So online people, Prabesha is here. That you and the next one, I'll give the application to Manjula. You can you hear me now, Prabesha? Can you hear me? Just reply again. Can you? Yes, sir. Okay, right. You lost your network connection. Try to reconnect. What's the problem here? And Russia, can you hear me? Just rename yourself when you're joining the Google Meet to call your name. Can you hear me? Online people. This one, not Prabesha. The next one. Okay, right. So I'll give the application form to Manjula. Take it and fill it out. So in the back side of the paper, I have given an example on how to fill the application. So take the instruction from that and fill your applications and give it as soon as possible. So people who give the applications will get the recording. If not, no. So make your email addresses much simpler. So I can read it properly. Fine. Okay. And the next thing is to your this question tute. Who brought your question tutes? Question tutes. Ah, right. So in the question tute, turn into page number what? Page number, that box. Page number 16. You have those tables, right? So there are 3 times 4, 12 tables, 12 boxes. So I say that I'm giving the answer scheme. So I didn't have time to digitalize this. This is my scratch paper, the thing that I have to type again and give you all. But since there's no time, I wrote it and I just photocopied. So you can see it. Okay. There are some cuttings and cut downs and breakdowns because this is my scratch paper. So this is the answer scheme. So 1, 2, 3, 4. Yeah, 4. Okay. Yes, more. Just tell me. You didn't receive me? I received. Okay. So at 14, I gave 14. 1, 2, 3, 4. 12, 13. Yes, printed 14. Why? Is there anybody who is not here? Everyone is here? Yeah. Okay. Right. Right. So after that, the next page, page number 18 and 19, essay questions. So basically, I gave the answer scheme for essay questions. These are the questions after that. So don't think about the spellings, but you have the knowledge. You can see it and refer the 1, 3. Check it. Yeah, yeah, yeah. Look in the back side. I have mentioned it. Email, you have to write in capital letters. So I know that email address is in simple letters. I know that. Okay, so don't worry. Write everything in capital letters. Okay, so these are the answer schemes. So for the MCQs, I on the day when I was doing the tute, I gave the answer scheme for some almost 50 questions, I guess. Not 50, like 20 or something. Yeah, 27. So some of the MCQs we did it right, and I gave the answers on the spot. So again, I will give the answers for all 135 questions because I had no time to revise it because there was a lot of errors in there. I again made the tute and the digital copy is there. I can't reprint this again. So here the mistakes are there. So next week or tomorrow, I will provide the answer scheme for other questions also, right? Okay, so don't worry. Just check your essay questions. If you didn't do the essay questions, if you didn't do that particular essay question, look at the question how I did it. Just read it. Do that question again, the question that you looked from me, and from that, keeping that in mind, try the next question without looking the answer scheme. Okay. After that, compare your answer and my answer. If it's okay, all right, fine. If there's an error, just again do the third question by looking at my answer scheme. Okay. Then do the fourth question by yourself. Then check the fourth question with my one. If it's correct, fine. If it's again wrong, do other questions also. Likewise. Understand? Right. So this is practice to your structured essay as well as the essay question. So normally when I was writing these questions I didn't write it somewhere else. I just wrote it by hand on the spot. Okay. So you can see that from question to question I have decreased the steps, like I have optimized the question I have written the answers in a shorter methods. Sometimes when it gradually like the final question PV equal NRT, I have drawn a table and like a beautiful stuff. I have drawn table and written the answers. So the thing that I'm going to say is when you're writing questions, you should gradually practice to use the adequate space as well as you should minimize your steps. You should write everything clearly. Understand? That's why you have to practice to the answer scheme. And the essay questions also. Okay. Excuse me. I'm looking at you. Okay, right. So we are going to move on to the error estimation part. Okay, this is a little bit different, and this is from the stuffs that we learned in the first, not the first tude, in the practical tude. Okay, can you remember the types of what errors? Okay, take your practical tude if you have that in your hand. Take your practical tude. Go to page number 3. Errors by the measurement. Okay, errors when you're taking a measurement. Right, zero error is not an error when we are taking the measurement, right? It is a, what's it? Systematic error, random error. It's a systematic error. Just go and just check it. Systematic error, you have two, calibration and zero error in under the instrumental part. You have personal errors and you have errors by external factors. And under random errors, you have object and the measurement, the process. So from the process, there are there are errors, and to quantify it, quantify in the sense to tell how much error this is, we use 3 types of methods. One is absolute error. It's same as the least count, and the next one is fractional error, and the other is percentage error, right? So now we are going to see how this affect the final calculation part. Okay, so we know that if we take a measurement, let's take I measured the length of this AC remote, okay, let's consider this 10 centimeters. So it's going to be 100 millimeters. If I measure this from a ruler, meter ruler, the least count is 1, right? So it's going to be plus or minus 1 least count, and this is going to be millimeters. Understand? Understand? Okay, so what's this? This is the least count as well as this is the what error? Absolute error. Fine. So this is a direct measurement. This is the length of the AC remote. So to find the area of the AC remote, can you directly take the area of the AC remote? No, you should have another measurement. What's it? The width or the breadth. Let's call it the breadth. This is the length, and let's find the breadth. And let's assume that it is 50 millimeters, 5 centimeters. Again from the meter ruler, plus or minus 1. Okay, fine, right. So people tell me what's the fractional error of this L length? Fractional error. Fractional error. Fractional error, not percentage error. What's the fractional error? Fractional error means the least count. Fractional error is the least count over the what? The reading, over the reading. Don't want to memorize this. I explain this again and again and again. Fractional error means the least count over reading. So exactly this is not the original equation. The original equation is absolute error over reading. So in our A-level syllabus, Sri Lankan A-level syllabus, this absolute error is taken as the least count. So the least count is taken as the absolute error. So no worries, we can use this formula, least count over reading. Okay, least count over reading. So let's go to the previous page. Okay, so what's the fractional error of this? 1 over 100. Okay, 1 over 100. Okay, I'm going to write, they're asking the fractional error. I'm going to write fractional error is equals to 1 over 100 and put this mark. Is this correct or wrong? Is correct or wrong? Fractional error, fine. I kept it as a fraction. Is it correct? No. Fractional errors, the final answer you should keep it as a decimal. Can you remember that we get a value as 0.048 and we made it 0.05. Can remember it. That's the fractional error, and when it became the percentage error, it became 0.48 or something. Okay, so what we have to do is, when we are finding the fractional error, sorry, so reset it again after the current went, current or whatever. Okay, so the fractional error, I'll write fractional error is going to be 1 over 100, and this is going to be equal to 0.01 millimeters. Is it millimeters? No, it doesn't have a unit. Why? Millimeters cancel off, no units, just a numerical value. That's a ratio. So this is the fractional error, and if we take the percentage error, we are going to multiply the fractional error by 100. Percentage error, we are going to multiply this 0.01 multiplied by 100, and this is equal to 1%. Is this allowed or not? Is this percentage allowed or not? Is it accurate or not accurate, this reading? What's the limit? The maximum limit using percentage? 1%. If the percentage error is 1 or less than 1, we consider that reading as accurate reading. If it is more than 1%, it's going to be inaccurate. That is just a law, a rule. Okay, rule. You can take more than that and you can assume that it is accurate, but globally, internationally, Sri Lanka, we believe that if it is less than 1, equal or less than 1%, it's going to be accurate. Fine, right. So this is the percentage of fractional error. So I'm going to find the fractional error of, stop your unnecessary talkings and stuff. Okay, you can understand, don't disturb the other person. Okay, sometimes he can't have the talent that you have. Okay, so don't disturb your friends. Just when you're focusing, okay, you can have whatever the talents, but the other person nearby you will have talent or not. You can't say that. So just don't think about only yourself, think about others also. Okay, right, fine. So this is fractional error. So this is going to be 1 millimeter over 50. 1 over 50. This is going to be how much? 0.02. Okay, 0.02. So the percentage error is going to be 0.02 multiplied by 100, and this is going to be 2%. Okay, so is this allowed? No, that's obvious. This is greater than 1%, so this is not allowed. So this is an accurate measurement, which the length, this is the length. So the length can be measured by the meter ruler, but the width, can it be measured by the meter ruler? No, we should use something which has least count less than 1 millimeter. So we are going to use vernier caliper. Okay, so let's assume that we used and we found the reading. Okay, now don't think about those stuff. We didn't use a vernier caliper. Still, we are in this process. Okay, no. Right. So you'll know that the error of the length is 1%. Okay. Error of the breadth is 2%. Okay, fine. It's fine. Now, the ultimate goal of my is to find the area of this remote. That's the ultimate goal that I have. Okay, so after I take the area, I can multiply this 50 by 100, and it's going to be 5,000 millimeters squared. Fine. So 5,000 millimeters squared, I got the area. But do I know the error of this area? The error from this area, from this or by this area, or error of this area? Do you know it? No. Why? It's an indirect calculation, indirect measurement, right? So for stuffs we don't know, that means for stuffs we didn't measure it directly, you have to use this part. Which part? Go to page number 7. Calculation of percentage error of derived physical quantities. What? Derived physical quantities. So the fundamental quantities, only the fundamental quantities can be measured. Normally the fundamental physical quantities are the quantities that we can measure directly. Sometimes there are some physical derived quantities that we can measure, but mostly we should be able to measure the fundamental quantity, fundamental physical quantity. You have how many fundamental physical quantities? 7. Okay, right. So what I'm going to do is by finding the errors of the direct measurement, I'm going to find the error of the area. How much does this length cost to the error of the area? How much does this breadth cost? So totally, the for example, I'll just give a summary. Since area is equal to length into breadth, okay, length into breadth, the error is going to be add up. Okay, so let's talk about later by doing this sum. Fine. Okay, so this is why you are going to determination of absolute error or density of the derived physical quantities error. Fine. When measurements are multiplied or divided, percentage error can be calculated by adding all the percentage errors. What's it? When measurements are multiplied or divided, percentage error can be calculated by adding all the percentage errors. Multiplied as well as divide, they have mentioned it, right? So if you have area is equal to length into breadth, and the error caused by this length is 1%, and the error caused by this breadth is 2%. So what's the error of this area? Is going to be the addition of these two. So it's going to be 3. This is the rule. Okay. So let's take give me some example for derived physical quantity with the division. That's it. Let's take density, not density. This velocity, right? Velocity. We are going to measure the velocity. So velocity is going to be displacement over time. So for displacement, I'm going to use a meter ruler, and let's assume that I know the fractional error, sorry, percentage error, and that's going to be 1%. And the time, that I used a stop clock, stopwatch, or a wristwatch, whatever the watch. Okay. So I used it, and the error caused by this time that I recorded is let's assume this is 3%. So what do you think? What's the error of this velocity due to these errors? Multiplication. There's a multiplication we added. So there's a division. What we should do? What should do? Huh? Subtract. Yeah, subtract. So from which one do we subtract? Which? I subtract 1 by 3. It's going to be minus 2. Okay. I subtract 3 by 1. It's going to be plus 2. So there are 2 errors. So is there a meaning of negative 2 error? What's it? Is there a meaning? So if 2% is the error, then negative 2% should be uh, super accurate. Not just accurate, it should be the opposite of inaccurate. Okay, it should be 2% times super accurate. Is it? No. So there's no method like due to addition of these two errors because of the multiplication, we are not going to subtract the errors here. Again, what we are going to do is we are going to add them up. Okay, whatever multiplication or division, we are going to find the addition of all of the errors, sum of the errors. So whatever the equation that let it be multiplication or division, we are going to add it up. So let's take this equation. Which equation? This volume is again V. Okay, it's again V. I'll write this V a little bit like this. Okay, this is a V, yeah, not 2 or something. This is V. So volume is going to be equals to length into breadth squared. Okay. So tell me people, error of by measuring the length is 0.2%. Error by measuring the breadth is 0.1%. Give me the error of this volume. Can anybody say that? Percentage error of the volume. Length, okay, length is a length. So this is 0.2. Okay, right. So there's a breadth is going to be 0.1. Okay, but so let's assume like this. So from here we can revise one part that we learned. 1, and this is also 1. Okay, let's assume this is also 1%. Can you remember that I read and important statement that if there's a power and the error caused by the physical quantity which has a power should be much higher than the physical quantity which has a lower power. Okay, I say this is extracted from the resource book itself. Those sentence was again duplicate. There was two sentences were the exact same sentences written in a different form. So go to page number what? Page number 5. Okay, go to page number 5. The fourth point. Go to the fourth point. What's the fourth point? When calculating the value of a quantity y given by y equal a to the power n b, the error of a influences much more than the error of b towards the error of y. Okay, so here let's take this is 0.1, 0.1. So error caused by each physical quantity is same. Okay, but according to this statement, they say that the error caused by the physical quantity which is raised to a power should have a much influence to this derived physical quantity. So from that, we can't take this 0.1. It should be greater than that. So here from this, we can conclude that it is not 0.1 greater than that. So if you have a little IQ, you can tell that's going to be 0.2. Why? This error is raised to power 2. And if you all know the basics, if you are going to go through the basics, I can do a little tricky stuff. V equals to length into breadth, and I'm going to write this again, breadth, multiplication of 3 stuffs. So this is 0.1, this is 0.1, this is 0.1. So totally these two add up, that is 0.2. So the total procedure is going to be 0.3. Understand? Okay. So take a question like this. I'll write a random equation. So let's take Q is equals to a to the power 4 over L into P. Okay. Just a quick question. The error caused by this is 0.1. The error caused by this is 0.2. This is going to be 0.5. Can anyone calculate the total error? What are you going to do? This L, does it have a power? No. So this 0.5 is going to influence all along. Okay. Let's take this P. Does it has a power? No. So that 0.2 is going to add up and is going to affect all along. Here this a to the power 4 is raised to a power, so that 0.1 is going to be multiplied by 4. This is the only thing. So 0.5 plus 0.2 plus 0.4 again. So it's going to be 0.1, not 0.11, 1.1 percentage. So finally we can tell that this is 0.5. Individually, if we consider the measurements, the measured values, the direct values, they are not in the error range. Why? It's 0.5 percentage, it's less than 1 percentage. It's 0.2 percentage, less than 1 percentage. 0.1, individually they are accurate. But you go to a derived physical quantity, those errors add up and that becomes 1.1. So people, we need to be so so cautious when we are doing experiment which has lot of variables, or we have to be cautious when we have a little bit of variables, lot of variables, right? So when you are going become like when you're going from advanced level to universities, it's really hard to do practical, and when you're finishing your 2 years, you will have an experience by doing a practical, and it's really hard because you have to cancel all sort of errors. Okay, the final reading and the theoretical value is not going to get equalized. Whatever time, it's not going to get equalized. Okay, so when you go to universities, it is like 50 100% times or 200% times there's a gap, because in after the advanced levels you are going to have equation which has a lot of variables. Last time I had an equation, it had 7 variables. Okay, so you have to know that, like if you go in a physical science stream, and if you want to be a scientist, you should have a good knowledge on how to avoid errors. There are people who does so however when you're doing practicals you have to have the practice to know how to cancel those errors. So when you're doing practicals at your school you will understand them. Okay, there are some people who will do the practical without causing any of the errors. Understand, they know when you're making one error they are going to cancel that error by taking the other measurement. We can do that. So we should have a good knowledge how we can cancel them. So those are the questions you are going to be asked from the structured questions, structured essay questions. How can you cancel these errors? What is the step that you can do to minimize this error, particular error? What is the steps you are going to do? Understand? Right. So in this part, in this particular, there's a question. This is a question. In this question, what we are going to do is we are going to find the error caused by the length, weight, and length, breadth, thickness, and the weight. We are going to find the total error of volume and density. Okay. So first of all, you should have data here. You have a box, you have a box like this. Let's take a cube. There's a cube. Take it the other way around. Like this. Will you tell me a way to right? Correct. No, no, no. Whatever. Fine. Just I'll draw one. Draw a simple one. Just don't confuse that with the picture in the tube. Okay. If not, I'll draw one. Fine. So take this, take this, take this. You have like this stuff, and have this thing like this. Way to connect. Okay. So mark these things. Don't speak. This is T. Is L W. So here length, width, and thickness. Okay, length, width, and thickness. For length, write it as 76. So you have a column here, you have a space here. Okay, I have given a space. In that space, you have to fill this. That's the data. That's the data. So length of the side, okay, length of the side L, mention it as equals to 76 plus or minus 1 millimeters. Plus or minus 1 millimeters. So can anybody tell me what's the instrument used to measure this length? What would be the instrument used to measure this length? The least count is 1 millimeter. Ruler, what ruler? Specifically in A-level syllabus, we mention it as meter ruler. Okay, not just ruler, meter ruler. Okay, right. The width of this is going to be 25 plus or minus 0.02. 0.02 is also going to be in millimeters. Okay. Width. Right. Use the spacer. Don't use more than that space. Try to write inside that box. You 25 ne? 25. It's like 6. Perfect. Just work on your S. That's really confusing. It's like theta. Yeah. Yes, it's like theta. No theta. Sorry. Right. Sorry. You okay? Write it. Write this. The width. Okay, fine. So once one old boy came, okay, he writes 5 like 6, 5 like this sort of thing. So it's really hard to read that 5. What I did was uh, like I gave him for 3 weeks. I gave him to write till that you have a max book, the small boxes. In a CR book to write 5 pages continuously for 3 weeks. Okay, because it was really confusing, and when we should make mistakes when we are doing it. If not, he's going to do it again in A levels, right? So if you have a small mistake, correct it up. Before it's going to get accumulated and a big mistake. Okay, right. And the thickness it's going to be. I'll write it here. It's going to be 2.10 plus or minus 0.2 plus or minus 0.02 millimeters again. Okay, can anybody tell me this width? What's the measuring instrument I can use to measure this width? Online to measure the width. What's it? I can't use meter ruler. Least count is 1 millimeters. Here, vernier caliper. Normally, the least count of vernier caliper is 0.1, but here it's 0.02. So this is not a normal vernier caliper. So it can be what vernier caliper? Extended vernier caliper. Okay. So most of the time, the usage of an extended vernier caliper is very low because of the coincidence, the parallax errors. Okay, the scales are going to be much closer. So most of the time, this reading is going to be taken by a micrometer screw gauge. Okay, let's move on to that stuff also. So it is 9:11:04. We came to last hour also, so let's hurry. Okay, so this is going to be 2.01 millimeters. So mass of this is going to be, that's in simple M. That's going to be 8.5 plus or minus 0.1 gram. And if you all want, you can mention that this is taken from an electronic balance or chemical balance. Right. Let's go to this lower part in the sense, online people, this part. You'll understand which part. Page, this second part, from top to bottom. We are going from like this and zigzag mode in this way, from here, here, and here, like this, and like this. Okay. So percentage error of length. I'll write percentage error of length. This is going to be how much? Can anybody find out? You'll know to find the percentage error. Just write the steps. You have given the least count is 1. You have given the 76 millimeters. So it's going to be multiplied by 100. That is equal to, just calculate it, and it's going to be 1.3 percentage. Fine. So next you have percentage error of width. It's going to be 0.02 over 25.5. Is it? 25.5? Why did I say? Just 25. They say just 25. Sorry. That's 25.5. Where is it? Where is it? This is just not just 25.5. Not just 25. This is 25.5. Put 5 here. Sorry. I didn't see it because I have written black color font over ash color, so it's hard to see it. Black color over ash, dark ash, is hard to figure it out. And I have a small eyesight problem also. I mean, short sight, long sight. Okay, fine. Write it 25.5. So this is 25.5. We are going to multiply this by 100, and this is going to be 0.078 percentage. Fine. So the percentage error of, you'll continue to do it if you'll know how to find the percentage error. 0.02 over 2.10. So here you can write this 2.1 rather than writing this as 2.10. So why did we write it as 2.10? So I said that when you're taking measurements, what you have to do? You have to mention this 0. Okay? Can become 0, but it's the place where your least count is going to come. The place where your least count is going to come. Understand? Okay? So the least count is here. Oh, that's why this has become a 0. They have kept that 0 because that's the place where the least count is going to come. So when somebody gives you 3.1080, okay, and the next reading is going to be, let's tell, they have given some 3 readings. It's going to be 0.82, and the next reading is going to be 0.1083. These are the 3 readings, and again they have given 1.0 8, not 83, this is 84. Just think, there's a question, A-level question like this. This is 84 and this is 86. Can anyone tell me what's the least count of this? Least count of this. So the least count is going to come to this place. So it's going to be 0.000 something. Okay. So we don't know what's that digit, 1 or 2 or 3 or whatever. So let's take it is 1. It's 1. So there should be some odd readings also, né? But here everything is even. Okay. So 1 it can't be, because there are 4 readings. We can tell we took 4 readings, and in 4 readings we didn't get any 1s here. So we can't make sure that 1 is the least count. But if we take 2 here, this digit is going to be 2. Can come, can come. When 0 vernier scale is coinciding with the main scale, can come. So this can, this can, 2 least counts, this 3 least counts. So this can be 2. There's a higher percentage of this to become 2. 3, again no. 4, again no. Right? We can't take from 4, we can't take this 2. 1 times 0.004 is going to be 0.004. So 4 can't, 5 can't, 6 can't, 7 can't. What's the least count then? Most probable least count 0.000. Understand? There's a question like this in A-level. Okay, by looking at the reading you should be able to find the least count. Okay, that's another way to find the least count. Right, erase this part and continue this. After that you have mass, I guess mass ne? It's how much is it? 0.1 over 85, 0.1 over 85, 85 or 8.5, 8.5 multiply by 100 is equals to, multiply by 100 is equal to, this is going to be thickness is going to be 0.95, 0.95. This is going to be 1.17, 1.17. Okay. Since we are not going to finalize these percentage errors, we are not going to round it off to 1 digit. Can you remember? Yeah, that 1 digit came. Come, go to those important factors again to page number 5. Page number 5, read the last statement. The measuring instrument, blah, 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 blah. As an example, a meter ruler calibrated in meter scales, least count is 1 millimeter. Because of this, we cannot obtain an accuracy more than 1 millimeters from a meter ruler. According to this, we can express a measurement such as 16.3 centimeters or 16.4 centimeters, but not as 16.35. Not that one. Sorry, not that. This one. Sorry. First point. As we usually require error to only one significant figure. Highlight that part. Only one significant figure. Figure in the sense 1 digit. Not 1 digit. One integer which is greater than 0 and less than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So that's how we express an error. But here, since these are not final errors, we are not going to make it to one significant figure. Why? We are going to find volumes, the error of the volume. Okay, these part are finished. So I'm moving to the next part here. Volume is going to be equal to 7.6 7.6 Right. We are going to calculate the volume 7.6 multiply by 25.5 multiply by 2.1 millimeters millimeter cube. Okay, fine. Let's see why we are finding. You would think that why we are finding the volume. Okay, I'll come to that point. So after this, you are getting 4,069.8 millimeters cube. You are converting this to centimeters, and so that you are dividing this by 1000. Okay, just think why we divided this by 1000 millimeter cube. So the final answer is going to be 4.07 cubic centimeters. Okay, like this, right here. Note it down here, volume part. Okay, the difference between milli and centi is 10 to the power 1. So here cubed, so 10 to the power 1 cubed, in the sense that's going to be 10 to the power 3. So that's why we divided by 1000. Okay, be familiarized with this stuff. Okay, fine. Let's go to density. Density is equal to mass over volume. This is going to be 8.5 grams over 4.07 centimeter cube. So it's going to be equal to 2.08 gram per cubic centimeter. Okay. So what we are going to do is, here we are finding the volume, and in another step we are going to find the percentage error of volume and density. How we are going to find the percentage error of volume and density? Volume is made up by length, breadth and thickness. Length, width and thickness. We are going to add the individual errors. Likewise, we can find the error of volume. Error of density, we are going to add the error of the mass, error of the volume. Okay, then we will get the error of the density. So what we are going to do is, now we know the percentage error of the percentage error of the density as well as percentage of the volume. We calculate this thing that we calculated. Okay, so we know the percentage error of the volume as well as the percentage error of the density. From that, can I find the percentage fractional error from the percentage error? From the percentage error, can I find the fractional error of the density? Yes, divided by 100. Can I find the fractional error of the volume? Yes, I can. Percentage you are converting to a fraction by divided by 100. I can find it. Can you find the absolute error? What's absolute error? Okay, let's find how the absolute error is there. So absolute error divided by reading is equal to fractional error. Okay, I know this. I can find the fractional error, right? I know the reading. How do I know the reading of the volume? Do I know the reading of the volume? I know. Calculated it. Now I know the volume, right? So can you find the absolute error? Yes, multiplying this reading by the fractional error. Understand? That's how we find the absolute error of a derived physical quantity. Understand? By going from percentage error to fractional error to absolute error. Okay, after that we can write volume this much plus or minus this much. Understand? Volume this much plus or minus this much. And here we are going to write the absolute error after the plus or minus sign. So the maximum volume can be this plus this. The minimum can be this minus this. Understand? I said you the highest, the most highest, the highest, what? Where is it? It's here. I mentioned it last week. Here, where is it? Okay, don't mind it, but I'll tell you where it is. Oh, I didn't tell you. I think I didn't tell you. So let's take that this part, and let's take that you got a reading from a meter ruler, 20 millimeters plus or minus 1 millimeter. Okay, this is the reading. So this is the reading. This is the least count, absolute error. So the maximum reading can be the highest. The word is highest possible. Highest possible reading can be highest possible reading can be what? 20 millimeters plus 1 millimeter. Understand? That's the highest, the error that can occur, the highest error. Understand? So we got the 20, but it can be 21. The lowest possible reading is going to be 20 millimeters minus 1 millimeter. Okay. So likewise, by finding the absolute error and writing with the reading like this is the reading and this is the absolute error, reading and the absolute error, we can find the highest possible density, highest possible volume, lowest possible volume and the lowest possible density. Okay. So so you have every data here. You can calculate the percentage error as well. You can find the other parts also. So do I need to do the other rest of the parts? Okay. So I gave this to copy down is because 0.1 you are, if you are going to divide by 0.8.5, it's going to be different answers. It will be 4 to 3 decimal places. If you are going to round it off to the second decimal place, and if you are going to round it off to one whatever the decimal place as you wish, the answer is going to change. That's why until this I gave you all the direction. From here, what you have to do? You have to do the rest of the parts. Okay. So next class, let's check who got the correct answer. Okay. Right. So did you understand this part? How to calculate the absolute error, the fractional error, or the percentage error of derived physical quantity? Yes. What you have to do? Just add them up. Okay. If it's a multiplication, add them up. If it's a division, add them up. Okay. Right. Fine. Online students, did you understand? I need 2 answers. Online students, yeah, okay, good, yeah, oh, fine. Copy it down in your what? Qt. So you have to complete which part? Until this we completed. You have this part, and these parts. Okay, complete it time when you come into the next class. So the time is 11:90. Wow, I have plenty of time. So let's go to the vernier scale instrument, not vernier scale instrument, circular vernier, page number 17. Page number 17. The order that I jumbled the order, not like in the tute, okay? Because if I go like in the tute, it's going to take hell a lot of time. Understand? Like absolute error. After that, I'm explaining the absolute error. Again, going to vernier scale. Again, going to extended vernier scale. After that, going to instruments. It's going to be silly. So I have to give that in the tute because your mind should go in that way. Just read the tute and organize yourself. Now everything is here and there. What you have to do, read the tute and take it to the correct order. Understand? Okay? Right. So the reason that why I didn't give in that order is because this is like with the order of the resource book. Of the resource book I have given, but in resource book you don't have much information. Understand? Deep information, I mean the explanation is very, very simple. So it's hard to understand. Like normal students, if you can think and research about it, you can understand resource book. Fine. Okay, let's go to circular vernier scale. Circular vernier scale is exactly the vernier scale, just giving a kick in this and that direction. Okay, have a vernier scale, pink. So now let's use black. Can you see this? Ah, yeah. Can't. There are no color blindness. Huh? Other people. I have seen one. Give me a color. This. This is. Can you see it? Can you see it? Okay, fine. Boys. Not fine. Okay. Okay, let's use this color. This. Oh, this is good. So what we are going to do is to have main scale. You have the main scale here, have the vernier scale here, have the main scale again here. Okay, let's take there's a reading. So this is going to be the vernier scale, going to be the main scale. So everything is same. The only thing is you are going to give a kick here and here, this part, and this is going to get curved. Or taking a hammer and bring this down, the vernier caliper, and the vernier caliper is going to be like this. Okay, you can move this here and there. Understand? Exact things, exact principle. Instead of millimeters, you are going to have degrees. Okay, instead of 0 millimeters, you are going to have minutes. You know minutes. What's a minute? Not this clock minute. Exact same, like it. The principle is like the clock minute. Minutes in the sense is going to be 1/60th of 1 degree. Okay, fine. Now let's go to the circular vernier scale part. I have given a figure. It's really hard to find which is coinciding with which. Give me a spectacle. No, can't. You can't read it. The resolution is very low. Circular verniers are used instruments such as Circular verniers are used in instruments such as ferrometer and theodolite. Okay, ferrometer, that's going to be one of your practical. Okay, the fourth one. Theodolite. What's theodolite? It's not in our A-level syllabus. It's in civil engineering. Theodolite, in the sense, it's exactly like a spherometer. There's a microscope. Okay, there's a stand here. Here. So just for additional knowledge, you have a stage. On that stage, you have a telescope here, and in here you have a little scale. A ticking clock. Okay, here they have marked the degrees. When you turn this, you are going to get a reading. So this is used to take an angle. I keep this. I focus this point, take the reading, again turn it, focus it to this guy. I'm going to take the reading. From that, I can find the angle between these two. So have you seen surveyors? Yes. Don't read it. I forgot the spelling. Those people who come to measure the land. Yes, surveyors. Surveyor. Whatever. Not important. That's survey. From that the word comes. Okay, understand? So let's read it. Above figure shows such a vernier scale calibrated in half-degree divisions. Half-degree divisions. Which scale? Vernier scale or the main scale? Figure shows such a circular scale calibrated in half-degree. So you have read a degree from a protractor. It's really small. Okay, half-degree in the sense is going to be half of this. So you don't want to make a protractor which is going to give only, which is going to increase the percentage error by only a double factor. Just a double. It's going to half the error. If you get a 1% error, if you're going to mark half degree in your protractor, it's going to be 0.5 error, 5%. You should get a reading more than this. What they are doing is they are taking the main scale and dividing it to, you get 1 degrees in, you have 1 degree divisions in a protractor. What they are going to do is they are going to break it to half. So what's the smallest main scale division? Length of smallest main scale division. Length of smallest main scale division. What's it? That's it. X. What's it? How many degrees? 0.5 degrees. How many minutes? It's going to be how many minutes? It's going to be 1 degree is equal to 1 dig is equal to 60 minutes. This is the symbol for minutes. So this is the symbol for degree, as well as you can use this whole this part. Okay. So once I wrote to the power -1. You write powers to units, right? You can write powers to unit. A millimeter cubed. Okay. I won't write this minus with this 0. So I want to make this cubed. So this is also superscript. This is also superscript. So this is going to be this. Okay. If not, it's going to be like this. I don't have to convert that. I think there's some other method. So I kept it like this. I didn't do any stuff. So Okay, right? This is equal to this. So here 0.5 in the sense that's going to be 30 minutes. Okay, again you can divide minutes into seconds. Okay, so 1 minute is equals to 60 seconds. It's same as the clock, Okay, fine. This is not relevant, so this is for additional knowledge. So what you are going to do here is, I hate this color, not white. Fine. So here you are going to divide this, and the lowest but length of smallest main scale division is 30 degrees. Okay, fine. What I'm going to do, I'm going to find the least count. The main thing, the main plot of an instrument is least count. Guys, shh. Pay attention, everyone. Least count. Tell me the shortest method to find least count. 1 millimeter divided by 10. So 1 millimeter is the smallest length of the main scale. So what's the smallest length of the main scale here? How much? 0.5 degrees. In minutes? How much? 30 minutes. So main scale is going to be 30 minutes. Fine. And they have given information. So how many divisions have they divided the vernier scale? Okay, now let's go. Vernier scale has 30 divisions. How much? It has 30 divisions. So 30 minutes divided by 30 divisions, the least count is going to be 1 minute. 1 minute. That means you are going to divide a small degree scale into how many parts? 3 parts. First, in normal vernier scale, what do? We divide that into 10 parts, just 10 parts. Here, you are going to divide this into 60 parts. Okay, then this is really hard to see the coinciding vernier scale. You'll think like that, but it is easy than a vernier caliper. Why? When it's curved, you are not writing this parallelly. You are going to write this in an angle way. So the length increases. Therefore, it's a little bit easier to find the stuff. Okay, so this is the least count. Okay, I found it. So you should be able to find the least count at the first glance, right? The vernier scale is 30. 30 vernier divisions are included in 29 divisions of 29 divisions or 14 degrees and 30 dash. 29 degrees. 29 degrees are divided into how many parts? Sorry, 29. Eh? That's going to be 29. Yeah, 29 degrees are divided into 30. 30 parts. This is the next way, long way. So least count means, what's the meaning of least count? Least count in the sense the gap between one main scale and one vernier scale. If it's an extended, it's going to be 2 minus 1. Okay. So here is it an extended one? I guess no. Because if you compare the gap of the vernier and the main scale, it's not double. Okay. I mean vernier, smallest verniers, how you are going to find if it is an extended or not? If the smallest of vernier scale division is greater than smallest of main scale division, what's this? This extended. The opposite of this, if this is greater than this is going to be a normal vernier scale. Understand? Here one vernier scale is smaller than one main scale, so we can use this formula. Understand, people? Understand or overstand? Huh? Okay, fine. So I'm going to find here 1. What is it? 1. What's the smallest division in the main scale? Is it 1 degree? No. What's it? 0.5 degrees. That means how many minutes? 30 minutes. So I'm not going to write it as 30 minutes. Why? What's the reason? Because I have written this in degrees. I'm going to write it as 0.5 degrees. So calculate this, you will get something. Okay. Now I can convert this to minutes as well. So this is going to be 30 minutes. 29 in the sense 29 degrees. How many minutes? 29 multiply by 60 minutes is going to be 30. So what can I do is to this cancel off. So this is going to be 2. So 30 minus going to be 58. 58 ne? 8 minutes. All wrong. 29. What's the wrong? What's wrong here? Wrong here. Here we mention 29 degrees divided into 30 parts. Okay. Minutes. Wrong here. 9 is going to have to multiply this by 0.5 ne. 29 division. 29 divisions, not degrees. Sorry. Not 29 degrees. You're going to do this sort of error. Why it's not 29 degrees? Why is it? They have said that 29 divisions of the main scale. So one main scale division is 0.5 degrees. What I'm going to do is I'm going to multiply this by 0.5. Understand? Understand? Okay. So again, what I have to do is I have to multiply this by a half factor. So 58 divided by 2 is going to be again 29. Okay, fine. Now I got the answer. So this is going to be 50 divided by 2. 2 to this 2 cancels off. 2 to this 2 cancels off. Okay. So this is going to be 29 degrees. 29 minutes is going to be 1 minute. Okay, fine. Well, don't need to copy this. I think it's going to be in the spherometer part. Okay, because of this calibration, the vernier can be read up to 1/60th of a degree. That is 1 minute. Consider how to obtain the readings indicated in the diagram. The diagram, you have to find it, and the zero lies between 170 and 173. Circular scale can read up to half 30. Since 14th mark of vernier with the mark of the circular scale, the correct reading is in this. Okay, what have they said? They say that they're going to take the reading. So reading is going to be main scale reading before the 0 of the vernier scale plus the number of coinciding vernier scale multiplied by the least count. Okay, so I'm going to take this reading. So they say that the 0 lies between 172 and 173. So which one should I take? 172 or 173 here? Which part? I'm going to take the 172. 172 degrees and 30 minutes. They say the 14th division coincides. So 14th vernier scale multiply by, what's the least count? In minutes? 1 minute. 1 minute, right? 1 minute. We found it. 1/60th, 1 minute. So this is the reading. So this is going to be 14 degrees plus 14 degrees. This is going to be 172 degrees 30 minutes plus 14 minutes is going to be 172 degrees 44 degrees. Hey, understand? This is the answer. Okay, this is how you take a reading. The only harder part is that minute thing, minute conversion part. And however, you have to find the least count, the shortest method. You all know what's the shortest method? Smallest scale, smallest length of smallest division of main scale divided by number of vernier divisions. Okay, 0.5 degrees divided by 30, or 30 minutes divided by 30. Okay, fine. So that's how we find it. So vernier scale using instrument. So that's the part of vernier scale. So vernier scale is using instrument in GCA level. You use vernier caliper. In vernier caliper, you have a vernier scale. In traveling microscope, you have a vernier scale. In spherometer, you have a vernier scale, but it's a circular one. Fine, right. So after that, we have screw principle. Before going to that, let's do a small question. Take your tute, vernier caliper tute. Go to page number 9. Page number 9. Page number 9. There's a one circular scale question because this is a vernier caliper tute. I can't put it, so I just borrowed one question. So here, okay, start do it. I'm not helping you all. You should start to do it. Not here. Tute. The tute that I gave you all today. Page number 4. Questions in the question part. Page number 4. You have a circular scale. JBL, the long form of JBL, Justin Bieber Limited. JBL. What's the meaning of JBL? The brand which makes subwoofers. That's it. Not Justin Bieber, just say. Okay. So after writing the answer, just hands up and I'll come and check it. So I have mentioned the which vernier scale coincide with the main scale. I have mentioned it. So it's much easier. What's the least count here? Uh-huh. Okay, fine. That's it. It hard. What's the main scale reading? Only the main scale reading. 32. That's in front of 0 of the vernier scale. Now, what's the coinciding vernier scale? 7. That's all. What's the next part you have to know? Least count. How are you going to find the least count? Main scale division divided by number of vernier scale. How many vernier scale divisions are there? 10. What's the main scale smallest division? You have marked 30 to 35. Between there are 5 divisions. So one is going to be how many degrees? 1 degree. So 1 degree, this is how many minutes? 60 minutes. So 60 minutes is the main scale lowest distance. 60 minutes divided by how many divisions? 10 division. So the least count is how many minutes? 6 minutes. 6 minutes. You understand? Don't worry. This happens every time. Can you hear me, online students? Okay. Yeah. So the main scale reading before the vernier scale is how much? 32 degrees. Fine. 32 degrees. So how are you going to find the reading? Read main scale reading, that is 32 degrees. Okay, I found it. Which vernier scale is coinciding? 7th vernier scale multiplied by the least count. How are we going to find the least count? Main scale smallest division. They have given 30 degrees and they have given 35 degrees. Between there 1, 2, 3, 4. So there are how many gaps? 1, 2, 3, 4, 5. That means 5 degrees divided by 5. How many degrees? 1 degree. I'm going to write 1 degree and how many vernier scale divisions? 10. 10 vernier scale divisions. Okay. What I'm going to do is 32 plus 7 divided by 10. 0.7. 0.7. What's this? 0.7 what? Degrees. So this is 32.7 degrees. Or we can do it in the next another way. This is equal to 32 degrees plus 7 multiplied by 1 degrees. I'm going to convert this to minutes. Over 10 is equal to 32 degrees plus 7 into 60 minutes divided by 10 is going to be equal to 32 degrees plus this to this I can cancel off. 7 times 6, 42 minutes. So the final answer is going to be 32 degrees 42 minutes. minutes. So within a week, going to come Charles. when it's going to come DNA tonight, tomorrow. So don't get fed up, okay? You know what's my oral results? Huh? No, someone said. I don't know. It can be tonight, tomorrow night, day after tomorrow, right? So once the oral results come, what most of the science stream students do is they change the stream. Huh? They change the stream. If you have a dream, if you have a dream, die for it. That's my quote. Okay. If you have a dream, die for it. Don't consider whatever the condition you are. You can be abnormal. You can have no fingers, no hands, no legs. You will know Nick Vujicic. It's in English pupils book, I guess. His story. He doesn't have hands, but he has did his life better than a normal person who has hands and who is just taking beggars, who has every stuff, and he can do a job, but he's begging. But this man doesn't have hands, doesn't have legs. He has children also. Understand? He has married. He's a pilot or something. I can't remember. He has gone through a nice job. Okay. So when you have a goal, die for it. This is from an enemy. Can you find it? Which enemy? Some sort of a famous enemy. Find it. Find it. Where is it? Okay. So you can do the which tute? We have to go to the screw principle. Ne? Yeah, 4-5 minutes. Let's try. Okay. So finished? You finish? Right. So let's go to a small theory part. Just give you a concentration for 1 minute. You have a nut. You have a nut here. Okay. Screw nut. A screw nut. Once you rotate 360 degrees, boys, just 5 minutes concentration I need. That's all. 360 degrees. When you turn it one round, one full rotation, one full revolution, not revolution, one rotation. Let's consider that this will go 1 millimeters inside. Okay, I'm going to turn it this. So what they do is, this is going 1 millimeters. So they are going to keep here a reference point and another point which is going to move. Like this is the fixed jaw and this is the moving jaw. That's it. This red part is the fixed jaw. Okay, this red part is the fixed jaw and this yellow part is the moving jaw, and this is connected to this nut. Okay, so this can move. So now this is touched. Okay, so you turn it the next way around, you move it upwards, you turn full one rotation. So this is going to be how many millimeters? 1 millimeter. What you're going to do is, you're going to keep something here which is 1 millimeter in depth. So you can keep something after, when this is going to turn one revolution round, the thickness of that part is going to be how much? 1 millimeter. Now tell me guys, what if I turn this 180 degrees, half rotation? How much? It's going to be, the length between these two is going to be 0.5 millimeters. Okay, what I'm going to do is, I'm going to turn quarter way around, 90 degrees. So this is going to be 0.25. I'm much greedier. Okay, I have to make this much lower. What I'm going to do is, divide this into 360 parts. I'm going to turn only 1 degree. What are you going to do? You're going to divide this by 360. Okay, so what you're going to do, 1 millimeter for 360 degrees. How many millimeters for 1 degree? Okay, let's take 1 divided by 360 is going to be 0.002. Okay, so if I move 1 degree, this distance is going to be, this distance is going to be this much millimeters. This is much lower than a vernier caliper. Understand? So this is the least count. If I can keep something which has the length of this, for example, we take a gemne, we are going to take a paper. Okay, if I can keep one paper and if it's going to get fixed between this paper and this thing, so what's the length of this paper? This much. Now I keep another paper, a paper which is higher GSM. You all know GSM, ne? When the GSM is here, the thickness is going to increase. And I turn this nut. Okay, now I can see it is coincided to, let's take there's something arrow here with, which is going to coincide with this thing. So when this is going to touch, this is going to be 0 degrees. Okay, you turn it up, screw it up. You keep a paper which has some sort of degrees and you turn it around. And now this coincided 2. So the least count is this much. It coincided with 2 degrees. So this is going to be multiplied by 2. Now what's the thickness of this paper? 2 times this part, 0.04 millimeters. Understand? This is known as the screw principle. This is used in micrometer screw gauge. How brilliant people can think. I mean, human can think. Right. What they are going to do is, they are not going to divide this to 360 degrees because 360 is a different sort of measurement. normally we divide a lot of stuff into multiples of 10. So what we are going to do is this is a multiple of 10, not multiple of 10, power of 10, 10, 100, 1000 or something. So here this length, which length? The length when the main scale, let's consider this is the main scale, whatever the scale, one part of scale, when one part of scale is going to move, the length that's going to move vertically up and down is known as the pitch. Okay. Now let's read. I just gave you just Dalada Sok Dumna. Now let's read it. The summary. Screw principle. When taking a measurement such as a thickness of a normal ruler, 2 millimeters, using an instrument which above mentioned vernier scale, the percentage error is very large. When you are going to measure the thickness of a ruler using a vernier caliper, then the percentage error is going to be very large. Okay, now see this. What's the least count of a vernier caliper? Normal vernier caliper 0.1 millimeters. So the maximum, the minimum that you can measure here is going to be multiplied by 100. This is going to be 10 millimeters. So you can't measure something which is less than 10 millimeters from a vernier caliper. That means 1 centimeter. If you are going to measure something less than 1 centimeter, you are going to make a percentage error more than 1%. Understand? Okay, right. This is a shortcut method. You multiply the least count by 100, you get the minimum length. Okay, which is equal to 1%. Okay, because this is the 1%. You're going to multiply with this 100. Sorry, not that. You just think it. I can explain it, but not now. That's not the time to explain it again. Okay, fine. So this is 10 millimeters. So to measure something which is smaller, like 2 millimeters, we can't use vernier caliper or extended vernier or whatever. 2 millimeters or 1 millimeter. So we have to use something which is much accurate. So we go to screw principle instruments. There I have given the calculation 0.1 divided by 2 multiplied by 100 into 5. So here 2 millimeter, so I divided it by 2, the reading. To minimize the percentage error of a measurement, we need vernier scales with other fractions of millimeter. So we need a vernier scale with other fractions of millimeter. Okay, I said that we are going to go to an extended vernier caliper. Okay, we know that vernier scales can be constructed by dividing the range of certain divisions of a linear scale into another equal divisions. By dividing the vernier scales, vernier scale by many divisions, we can make the least count much smaller. Okay, 55. But as the number of divisions are large, it is difficult to observe from the naked eye which division of the vernier scale coincide with a division of the main scale. Sometimes it is difficult to observe using a magnifying glass also. Okay, I said why it is hard to observe by a magnifying glass also. What's the reason? Because it's hard to print. Let's say we can print, but if it's hard to read, we can use a magnifying glass. Okay, but if it's hard to print and if the cost is much higher to produce something which is much thinner, no point of making those stuff. Okay, just the cost is higher. So that's the reason why we are going to a screw principle. Because of this, as a result of experiment done to obtain measurement like thickness of a paper, the screw instrument were produced. So the screw instruments were produced. When a screw is rotated, it moves either forward or backward. We all know that, forward or backward. Based on this moving distance and the angle of rotation of the screw, understand? Angle of rotation of the screw and the moving distance, instruments have been constructed to measure small lengths more accurately. When a screw is rotated a full round of 360 degrees, the distance it moves is equal to the distance between two consecutive threads. What's it? When you rotate something 360 degrees, it's going to move some length. That length is equal to the length between two threads. Threads means you have a nut here. Between this thread, if the length is 1 millimeter, you are going to rotate 360 one rotation. If you are going to complete one rotation, the length this nut moves is going to be 1 millimeter. So this is equal to the length between the thread. That's what they are saying. Understand? Right. This distance is known as the pitch of the screw. This is known as the pitch of the screw. When the pitch of the screw is known, when we know the pitch of the screw, the distance moved by the screw can be found corresponding to the angle of rotation of the screw. With the angle, we can find the distance it moves. Suppose that a screw has a pitch of value x. Let's take it has a pitch of value x. So in one rotation, it's going to move x. Okay, x number of linear scale, linear length. When the pitch of the screw is known, the distance moved by the screw can be found corresponding to the angle of rotation of the screw. Okay, we can find. Suppose that a screw has a pitch of x. It has calibrated heads consisting a scale of n divisions. What? The pitch is x. That means what's pitch? When you complete one rotation. So first of all, in the previous example, I explained pitch is this. This is not pitch. I'm sorry. This is the least count. This is the least count. This is not the pitch. Which means when you complete one rotation, it moves a vertical distance. That distance is known as pitch. But this is not the pitch. Sorry. Totally sorry. This is not the pitch. This is the pitch. What's it? When you complete one rotation, it moves 1 millimeter, I said it. So this 1 millimeter is the pitch. Complete one 360 degrees. Okay. The length it moves is going to be. Wake up. Last minute. You have only 1 minute or something. Wake up, everyone. X. So this is known as the. Is known as the. If it's hard, if it's health problem. Okay, sorry. If it's hard, just leave it. It's okay, fine. So because we are moving to screw principle now, a little bit different. So you have to have the concentration, right? So how we are going to find is x is the pitch, and the screw is divided into how many divisions? N number of divisions. Okay. So when you complete, it's going to be n number of divisions. How much length is going? X millimeters it's going. So distance moved by the screw when it rotates a full round of n divisions. After that, have I given you to fill? Pitch of the screw, pitch of the instrument. The screw rotates a full round of n divisions. Here in this part, I have mentioned here pitch of the instrument. Pitch of the instrument. This is not pitch of the instrument. This is not pitch of the instrument. Make it least count of the instrument. Wait, just wait a second. Here, cut that pitch of the instrument. It should be something like this. Everyone, cut that pitch of the instrument part here. Cut this part. It should be like this. Give me just 5 minutes. I can complete this. Distance moved by the screw when it rotates through one division. That's it. Distance moved by the screw. Moved by the screw when it rotates through one division. When it rotates through one division. Through one division. Okay, the long part. So this is the exact least count. You have to put a curly bracket here and mention this. You move x length. How many divisions do you have? N number of divisions. So this is the distance moved when the screw by the screw when it rotates through one division. Okay, one division out of n. X divided by n. So after that, you have to highlight the statement there. X over n is the least count of the instrument consisting of this screw. So how we are going to find the least count of an instrument which uses the screw principle? We are going to divide the pitch by the number of divisions of the circular scale. Right. I have flipped everything. So write this statement and X over n. Highlight this part. There's a small sentence here. There's a small part. Highlight it. And somewhere, if you have a space here, write in a big block. Make a box using some color pen, and least count is equal to X over n. So make it and highlight it. Okay, screw principle using instruments based on GCLL syllabus. The following instrument need to be learned: micrometer, screw gauge, and spherometer. So in micrometer, screw gauge, you have vernier scale as well as the what? The screw principle. It uses both of these principles, vernier principle as well as this principle. But in spherometer, you use only screw principle. Oh, okay. Right. So it's 12:03, done for the day, right? So I guess I completed this practical tute. See if there's any blank in this tute. I completed this. Errors. The homework is to fill this part. Which part? Error estimation part. Okay, next week I'll check it. And you can read this measuring instrument part. This is just a small part. This is not related to LLCL. This doesn't affect your marks. This is just a part. You can read it. Okay. About measuring instrument, like how to classify the measuring instruments. Meter ruler. How you can take readings from a meter ruler accurately, not just by keeping it like this and you can measure it. Okay. There are ways, and those ways are mentioned. Those are not exam focused theories. We have utilized it. After that, vernier principle, least count. So here the next homework is this, which example number 4, main scale of the spherometer is marked same as the circular vernier scale. We did a circular vernier scale in the next tute. Same thing is here. Okay, just check and complete the tute. We completed this reading, extended vernier scale, circular vernier scale, screw principle, and the only part remaining is the short note in this final part. Okay, you have some beautiful drawings here. You just have to mark them. Okay, that's what I had some space. I have to add something, so I added those instruments. Okay, fine. So done for the day. 4 people gave 5 people. Again, hands up. You, and you 4, and someone gave me 5. No. You gave me 2, ne? WIA. Akira. You. Again, you write WIA. Sineja. Simbol pita you. Netula. You. Telambu. So 5. You gave today. Huh? You gave today, all right. So can I neglect that WIA part? Is over, fine. So I'll use only Lakira, Dihen, that Amarkon. Amar Singh. Okay, fine. Thank you. Then bye. Best of luck for your results. Don't change your stream. That's a silly decision. My results was just a small one, 6A, B, 2C. I had A's for science and maths. That's all. C for religion, C for literature, and again C for Sinhala literature. So literature was easy. I did a very silly stuff there. Okay, online students, you can come and collect the tutes if you all want. I'll give the application form to Manjula. You can fill it. Okay. Bye. Goodbye.